Okay.
Yes, sir. It is visible now. It's clear.
Okay. Thank you.
Yes, sir. Respected today's resource person, Dr. S. Viswanadha garu, who is Professor of CSC JNTUH, Vice Principal, JNTUH College of Engineering, Jagtial, our Director of Institutions, Dr. C.V. Krishna garu, our Coordinator, Dr. K. Rameshwari garu, Dean School of Pharmacy and Management Science, and respect to heads of various departments. Very importantly, all my dear participants, very good morning to all of you. Warm welcome to the fourth day, first session of our ISTE-STTP program on machine learning applications and research challenges. We are very happy that our resource person today is ready to take up the second session. Yesterday we had session by him, which is on again artificial neural networks with real-time examples part 1. Now sir is going to continue. Yesterday I had given complete profile of sir. A few members might be new in this session. Once again I'll give sir's profile in brief, just in a minute. Dr. S. Raju, who is a professor in the Department of Computer Science and Engineering and Vice Principal, and has 24 years of experience in teaching, research, and administration. From December 2016 to till date, he is serving as Vice Principal, JNTUH College of Engineering, Jagtial. He has served as Director MCA, GRIT from June 2008 to July 2010. Then he served as Head of the Department of CSC, JNTUH College of Engineering, Jagtial, obtained MTech from JNTUH, Hyderabad, PhD from Acharya Nagarjuna University, Guntur. He is certified CMI in Education Leadership and Program Management, which is sponsored by MHRD, ISTE, and UKRI, Dudley College, London. He has been honored with the State Best Teacher Award 2020 from the Government of Telangana, Best Computer Science Engineering Award from ISTE-AP for the year 2014, Certification Appreciation Award in Independence Celebrations from Honorable District Collector Jagtial 2019, and Best Citizen of India. His research interests include programming methodology, machine learning algorithms, biometrics, and quality in higher education are globally recognized. He filed 10 Indian patents deriving from his research and relevant to education institutions. The research contributions are not only confined to his subject, but also extend to other related domains arising out of the new education system, assessment and accreditation, and their impact on Indian higher education. To add impetus to his academic credentials, he has undergone training as well as speaker for the quality improvement in education at NIITR. OSA stands for World Summit on Accreditation 2012. At the same time, in World Summit on Accreditation 2014, in TCS, Infosys, and NBA NAC, he guided 10 PhDs. At the same time, 5 PhD scholars are pursuing under his able guidance. He is a life member of ISTE, IIT, CSI, and IAC-SIT. He has 120 plus research publications in his credit in reputed national and international journals, which includes Scopus, SCS, Kangar, etc., and also conferences. He has authored 4 books and 11 book chapters and implementing 2 AICTE sponsored research projects, 1 TechUp project and 1 fellowship from Telangana State and Science and Technology. He has been a member of several governmental committees like JNTUH, AICTE, NBA, NAC, etc. He had delivered more than 70 invited talks, expert lectures, and keynote addresses on various technical topics, as well as outcome-based education, such as NBA, NAC accreditation process in the country and outside India. He has organized several workshops, seminars, tutorials, and conferences. He has visited Singapore and Taiwan and interacted with several academicians and researchers. With this brief introduction, I warm welcome you, sir, for our today's session. Thank you, sir. Thank you very much.
So thank you very much, Janardhan, sir. So shall I proceed? My voice is clear?
Very clear, sir. Please proceed, sir.
Okay, now I want to share the PPT. So today, I'll be going to discuss regarding the logical gates. In yesterday's session, we were discussed AND gate, and OR gate. In today's session, I'll be going to share NOT gate and exclusive NOR gate with a multiple layer concept. At the same time, I'll be going to concentrate on the research topic, which is doing by my research scholar. I hope you will be understand. This is a little bit complex process, but anyhow, I'll be going to share with you. So who are very much interested to go for the research, for them it could be helpful. How to apply the artificial neural network in the image processing concept. So that is what the title I have been defined here. The future enhancement of fingerprint recognition system. In this, how to use the artificial neural network concept. That is what the method is, autoencoder. So I have been given several methods are there, but in this example, I'll be going to select autoencoder. So this is. So who are very really interesting to do the research, I think the second topic is very much useful. So I'll give the brief information, not much as per the time constraint. Okay. So let us see here. So in yesterday, what we discussed, AND gate and NOT gate. So what were identified in OR gate when we were selected weights and bias values in randomly, then in the first row or second row or third row or fourth row. So this is what you see that in the first row, what we selected the randomly values W1, W2 and bias value. With this, I may be getting the exact results, what I expected. In the second row, when I used the same random values, W1, W2 bias value, with the help of these values, my expected value is 0, but our target value is 1. So there is a mismatching. So then what I did the updation of weights. So updation of the weights means there are 3 variables are there. One is a W1, W2, B is there. In these 3, which I have to be updated, that is also we discussed in yesterday's session. So should I update the W1 or W2 or bias value? So this is what the updation process. Updation process. Okay. With the, sorry, 1 second. Row 2, X1, X2. Same, I have been tested with the randomly selected values. Finally, I have not been achieved my target. So we went for the updation of the either W1 or W2 or B1. But with respect to my output, I have been applied the updation method for certain variable, means W1 or W2 or B. So how to take a decision means on the basis of the input values only. We must understand the input values. If I can change W1, what is the consequence? If I change W2, what is the consequence? If I change the B, what is the consequence? So like that, what we did, we have been updated the weightage values and other values also. This is what we discussed in yesterday's session. In today's session also, just I'll repeating NOT gate. In the NOT gate, you know that actually what is the definition of the NOT gate? Opposite of the input, you know that AB. So suppose if I give the input 0 for A, then what is the output is 1. So similarly, input is 1, output is 0, opposite. So now you see that here, my additive function is my additive function from the W1 X1 plus B, W1 X1 plus B. So and in this process, I'm selecting the randomly two input values of W1 and WB. So W1 is equal to randomly I'm selecting 1, B equal to -1. So when I selected this, then what is the X1 value? 0. So if I substitute all these values, W1 X1 plus B equal to X1 is a 0, multiply 1, 0, minus bias value is a -1, 0, -1, -1. So then what about my activation function? Activation function is Wi xi plus b less than or equal to 0. If this condition is true, then the value is 0. Otherwise, 1. So what I achieved the value with the help of this additive function -1. So -1 less than or equal to 0. Then y is equal to 0. So now y is equal to 0. My expected values, you see that with my formula, with my random values. So what I'm getting here, y is equal to 0. But actually my target is what? 1. My target is 1. So there is a mismatching. So there is a mismatching. So when the mismatching is there, immediately what I want to do, I have to go for from the sink to the source, from sink to the source, from out layer to the source layer. Why should I go for that? That means, so here is mismatching with the target value. So now I want to change the random values. Which value I have to change? Either W1 or B value. So this is what we want to discuss here. As the output is 1 for the NOT gate. So now we want values that will make input x1 equal to 0 to give y is equal to 1. So then as per the definition, if x1 is a 0, I should get the y is equal to 1. Now if we change b to 1, b already I have selected -1. Now what I'm doing here, I'm changing. Which one I'm changing? B only. Why I'm not changing W1? X1 value is a 0. If I change W1, no meaning. Why it doesn't have the meaning means 0 multiply anything is equal to 0 only. So in this case, which I can change, only the B is the possibility to change. If I change B, there could be possibility to reach my target value. So that what I did here, if we change B to 1, we have 0 plus 1. When I take the B is equal to 1, then already W1 is 1, 1 multiply, you see that X1 is 0, so that means 0. B is I'm taking as a positive. So 0 plus 1, 0 plus 1, 1. So now what is the value of additive function value? 1. So once I substitute here, 1 is less than or equal to 0. Then the condition is a true or false? Condition is a false. When the condition is false, it will be producing the 1. So then you see that my expected value is 1 and also targeted value is 1. So which I have been updated the B value. So it is giving the correct result. So that this random value is correct. Like this, I have to continue the process. So until reaching my target. From the perceptron rule, this works. Let's go for the row 2. After row 1, what are the random values of W1 and W2? You see that here, W1 already 1 is there. After updation of the B, now B is equal to 1. So now after the row 1, W1 equal to 1, B equal to 1. So now what I want to do, I want to compute the additive function. Additive function is what? W1 multiply X1. So what about you see that X1 is now 1. So second row. In the second row, here let us assume as a X1. Okay. So W1 is a 1. So 1 multiply 1 plus 1. So that means 1 plus 1. So equal to 2. So now I am getting the 2. So from the perceptron rule, if I substitute here Wx plus B, so 2 is greater than 0. So 2 is greater than 0. So then y is equal to 1. So then it is producing the y is equal to 1. But actual output, my target output is 0. My target output is 0. So what I am getting with my additive function with my random values 1. So these two are mismatching. These two are mismatching. In this case, what I want to do, I want to try to update the either W1 or B value. But in the previous row, I updated. Again, the problem will be repeating in the row 2 also. So what I need to do now here, this row is so incorrect. Whatever the result I receive, that is not mismatching, so that this is not correct. As the output is 0 for the NOT gate. Okay, output is 0, but I'm getting 1. So we want values that will make input x1 is equal to 1 to give y is equal to 0. If we change W1 equal to -1. So why I'm changing here is W1. So you see that x1 is 1. So if I change the W1, there is an influencing possibility. So that what I'm doing here, earlier W1 was 1. Now I'm taking W1 is equal to -1. So B is 1. So W1 is equal to -1. Now I apply the I compute the additive function. What is this additive function here? You see that additive function is W1 is a -1 multiply input value is x1 is 1. So -1 multiply 1 -1 plus what is the B value? 1. So that 1 minus 1 plus 1 equal to 0. So once I substitute the value in this activation function, 0 is less than or equal to 0. Once the condition is true, then the result is y is equal to 0. So when it has been converted into the y is equal to 0, when w1 is equal to minus 1 and b is equal to 1. So the same rule I have to be cross-check for the again row 1. So once I update, immediately I have to check with the previous all the possible rows only. So this could be applicable for all the rows. So from the perceptron rule, if wx plus b less than or equal to 0, then y is equal to 0. Therefore, this work for both row 1 and row 2. I have to cross-check what I updated the values at the last. W1 equal to minus 1, b equal to 1. So again, I have to be recheck with the row 1. Row 1 value x1 is 0. So 0, we see that 0 multiply minus 1, 0 multiply minus 1, 0 plus 1. So that definitely it will be 1 only. So 1 is means 1 is less than or equal to 0, condition false. Then definitely it will be produce the 1. So this is the process of the updation of weightage or bias. You see in this example, I have selected both, I have updated both the values, either W1 and B value. So this is the process we want to apply where the problem occur. What problem? Where the difference is there between the output value and target value. So until reaching that. So number of iterations means that depends on your ability, your capability, number of iterations. So this is what. So what are the steps for using gradient descent algorithm? So what we did in the previous method, initialize random weights and bias value. So what is the method we applied? First, I have been initialized the weightage value and bias value. Then what I did, pass an input through the network and get values from output layer. So what about you see that I have been passed on the values and with the help of this activation function, I got the output value. So pass an input through the network and get values from output layer and calculate error between the actual value and the predicted value. What I did, once I got the value this and this value, I'm comparing with my target value. If there is any error, then I'll go for the updation. Otherwise, I'll go for the next row. So this is the process we applied. Calculate error between the actual value and the predicted value. Go to each neurons which contributes to the error and change its respective values to reduce the error. So now what I want to do here is you see that so two values are there, W1 and B. So now which is playing the key role for influencing of the output. So that is what we identified with the help of the analysis. So go to each neurons. Here is in this example, only one neuron is there. Maybe in another example, there may be possibility 2 or more neurons also. So that is what neuron is a very prime component in the artificial neural network. Go to each neurons which contributes to the error and change its respective values to reduce the error. So which contribute the error means suppose x1, x2, x3 are there. Suppose x3 is contributing, then I have to change the W3. So this is the process we want to apply. Reiterate until you find the best weights of network. So this process you have to be reiterated until find the best weights of network. Until find the best weights of network means until reaching my target. I have to reach my target only. For that, what I want to do, I have to change the weights of W or bias value. So this is the process we want to apply in a backpropagation method. Please 5 minutes interaction. Any more queries regarding this? Any doubts, please, regarding today and yesterday's session?
Dear participants, feel free to interact with the resource person. If you have any questions, please post in the chat box, or you can raise your hand, or now you can straight away interact with the sir.
Shall I continue?
Yes, sir.
Thank you. My slide is visible, please.
Yes, sir. Visible, sir.
So now we'll be discussing feed-forward network. So this is unidirection network. It doesn't allow the bidirection. Okay, it is unidirection. The feed-forward neural network was the first and simplest type of artificial neural network. This is very simplest network and also it is unidirection. In this network, the information moves in only one direction forward from the input nodes through the hidden nodes and to the output nodes. So this is what the architecture of the artificial neural network. In the architecture, that there are three different kinds of layers are available. One is input layer, hidden layer, and output layer. Hidden layer is processing unit. Okay. As per this, you see that what is saying the information moves in only one direction forward from the input. These are the input nodes through the hidden nodes, and finally I'll be getting the result is with the output node. So there are no cycles or loops in this network. So feed forward network means it doesn't allow the cycles or loops also. So this is what feed forward network. Example. So I'll be giving the example for the feed forward network. So consider a simple neural network with two inputs, two hidden neurons, and two outputs with some random weights as follows. Let us see here, I am taking a sample network. A sample network means what I am considering here parameters, two inputs, input 1, input 2. And what I am asking another one is two hidden neurons, H1, H2. And what about two outputs? Two outputs means O1, O2. And remaining with the same with some random weights as follows. You see here, and also bias from layer to layer also. Layer to layer, I am taking here is bias value. So from input layer to hidden layer, bias 1. From hidden layer to output layer, bias 2. So like you see that this input is connected to both the hidden nodes, so that when it is their connection, so there should be some weightage for this input value. So that is what representing by certain notation, that is W1, W2, W3, W4, W5, W6, W7, W8. So like this, you see that this is what here. How many input nodes are here? Input 1, input 2. How many hidden nodes are here? H1, H2. And how many output nodes are here? O1, O2. So there could be possibility of the more than one input, more than one hidden nodes, more than one output also. So that it is a multi-input, multi-output concept. I think you know that multi-input and multi-output concept. So that can be multi-input, multi-output can be a single input, single that applicable in all possible cases. The step 2, consider some input values, random weights and bias values as below. You see what I have taken here, the example. So now what I want to do, I have to take the input and input values, weightages of the each connection, and again weightages of the each connection means these are the values I am taking here. Just I am giving the for understanding. Let us here input values, suppose I1, I2 like this, and bias values randomly I am selecting. The bias values are random only. Target values also random I have selected. Sorry, target value not random, my achievement, my requirement. This is what my requirement. These are the input values available. Okay, now initial random weights. Which are the random values? Bias and weightages, random values. Remaining two, it was fixed by me. So now you see that the input values are 0.05 and 0.10. Here you see that I have added to this now. So W1, W2, W3, W4. Like you see that whatever the random weights I have taken, I am attaching with this variable. You see W1 equal to 0.15, W2 equal to 0.20. So random values. So like once I have that information, I have the input values, bias values, target values, initial random weights. Now how to get the O1 and O2. So this is what the formula is. See that this is what we discussed in yesterday class also. First, I want to calculate the hidden layer node value. The H1 value and H2 value I want to calculate. How do I calculate the H1 value? You see how many edges are there regarding this node. So H1 equal to W1 multiply I1 plus W2 multiply I2 plus bias value. So this is the formula. You see that. Similarly, H2 you see that how many edges are there connected to this. So H2 is equal to I1 multiply W2, sorry, W3 plus I2 multiply W4 plus bias 1. So like this H1 and H2 you need to calculate. Once you calculate the H1 and H2 value, then you go for the output 1, output 2. Output 1 equal to, what are the edges are connected to this? H1 value. Already I received the H1 value. So with the help of this, so H1 multiply W5 plus H2 multiply W7. So this is the output 1. Similarly, you need to plus bias 2. Similarly, you calculate the output 2. Output 2 values, what are the edges are connected? H1 multiply W7 plus H2 multiply W8 plus bias 2. Okay, this is the way we have to calculate. The same thing I represented in a, let us see now, feed forward pass, you see that. Step 3. The neural network currently predicts given the weights and biases above and inputs. In the previous slide, we have been seen that inputs of 0.05 and 0.10, I have taken the values, you see that here for this value. The total net input to each hidden layer neuron calls the total net input using an activation function. Then repeat the process with the output layer neurons, calculating the hidden layer output. So this is what you see that H1 formula already I have told you, H1 value how to calculate. The same thing I am representing here, W1 I1 plus W2 I2 plus B1 multiply I1. So this is what the formula for H1. Similarly, H2 is equal to W3 multiply I3 plus W4 multiply I4 plus B1 multiply 1. The similar process only. You know the values of each and every variable, just you substitute it and you may get this is the value. So this is what the process. This calls the H1 value into the activation function results. So you see that now activation function results are here, you see that. So 1 by E4 minus X value. So then you see that you can use any one of the formula. So this is what repeat the same process to find the output 2 also, H2 also. Both I am taking and calculate the output value. Similarly, net 0,1 means O1, O2, O1 and O2 values. The process is the same, please, because of time is not sufficient. So the just simple calculation only. Okay, calculate the output values at 0,1 equal to the same which I have been explained to you in the diagram. The values only just I am substituting here. So you calculate the net O1 and O2. You see that O2, both the values you calculate it. Now let us see here the calculate the total error. So I want to calculate the total error. What I have been shared with you, the error value is target value minus output value. So total how many outputs are there? 1 by 2. So summation of target minus output. You see that summation minus target minus output. So 1 by 2 target 1, 0,1 minus output. So this is what I have been decided already, target value. You see here, this is the target 1, target 2. So now I want to find the, after finding the value of output 1, so then what is the difference between this? So this is the value is a difference like this. This is the value is a difference. Similarly, E2 also you calculate, then E total, E0, E01 plus E02. So finally, this is the value I'm getting. So what is this total error value? You see that the total. So now what I want to do, if I'm not reaching my target, then what I have to do, back propagation is to update each of the weights in the network. So now I have to be calculated like this error value, and then I have to try to find the appropriate neuron, which is more influencing. So that I have to be update, that weightage I have to be update in the network. So that they cause the actual output to be closer, the target output, thereby minimizing the error for each output neuron and the network as a whole. So like this, I have to be continue the process. How many iterations means that until reaching a target value. So this is what you see that process of the concept. So now I'm going to enter into the multi-layer networks are useful. Why multi-layer networks are useful? Let us see. So we up to now what we discussed means we discussed with the single hidden layer. Now we are moving to the more than one hidden layer. So there could be possibility of the more than one hidden layer, not only one single hidden layer. In this example, Let us try to understand how a neural network can model complex relations using multiple layers. In this example, what we are discussing, a complex relations concept only. Where the complex relation is there I want to introduce the multiple layers. Where the simplex method is there I should not require the multiple layer concept. The example of exclusive NOR function, I think we are all very familiar, so that I'm taking this is the example. Exclusive NOR function. Just to recap, the truth table of a exclusive NOR function looks like this. So this is what is the truth table. So x1, x2 values, and what is the output of the exclusive NOR gate means x1 exclusive NOR gate. If both the inputs are same, then the result is always true. Otherwise, result is false. So this is what the fundamental definition of the exclusive NOR gate. So now, but exclusive NOR gate is complex relation and are not a simple operations. This is what you see the derived operator. So where the derived operation is there I want to introduce the multi-layer concept. Otherwise, it could be difficult to solve the problem. So this sort of relationship cannot be modeled using a single neuron. So with a single neuron, it is very difficult. You see how many neurons are used for the NOT gate? You see that here. How many neurons are used? Only one neuron. So for AND gate, you see that only neuron, single neuron. But for the exclusive NOR gate, with a single neuron, it could be difficult. So that what I want to do, I want to introduce multiple neurons, okay, with a multiple layer concept. So what is saying? This sort of relationship cannot be modeled using single neuron. So thus, we will use a multi-layer network. So in this case, what I want to do, I want to introduce multi-layer. So here, there are two different kinds of layers are there. Single layer network, multi-layer network. So the selection of the network is very much important. When should I select the single layer and when should I select the multi-layer? With respect to the relation, whether it is a simple or whether it is a complex. So based on that, I have to take a decision. Should I go for the single layer or multi-layer? The idea behind using multiple layers is that complex relations can be broken into simpler functions and combined. You know that multiple layer purpose is what you see that when we have the idea about the simple layer process, then we are combining all these layers only. So the combination or maybe any particular method, simpler functions and combined. So you see that if I want to this result, I'll show you there are two possible cases are there. How to get this value. So x1 exclusion or x2. Okay, suppose. Let us see here. Let's break down the exclusion OR function. So exclusion OR function we are all very familiar. So what about you see that? So here is not x1 exclusive or x2. So this is one way. This is one way we see that. Not you see that a plus b and a dash plus b dash. So this is what the formula. This is another possible. If I want to solve, this is if I want to find the value of this. So like you see that. So this is what. So similarly you see that. Okay, not here. Here is plus means or option or operation and dot means and operation. So, okay, this you need to consider. So like this, you see that how many possible cases are there for the same exclusive NOR. So by this I can get or by this possible case. There are two possible ways are there for finding the exclusive NOR value. There are two possible ways are there. So how it is getting the two possible ways means the exclusion OR is a derived operation. It's not an individual. It is not a simple operation. It is a combination of several possible operations only. When it is a combination of several possible operations, it must be required several neurons also. So with respect to that only, with respect to the definition. So now let us see here. This is one possible method and another possible method. This is what you see that. So this. So two possible cases are there. Now I am selecting the first possible case. What is the case one? So exclusive x1 exclusion or x2 equal to a dash dot b dash plus a dot b. So this is equivalent to this one. Or this is also equivalent to this one. You see that not of a plus b dot a dash plus b dash. So in this case, how many AND operations, how many OR operations, how many NOT operations are there? You see that here is A not A, not B, not A and not B, and OR option. OR operation. So here also A and B. So like this, you see that now the same thing, how I am representing in the form of neural network. So this is what we are looking like. It is a in the CO like an expression, simple algebraic expression. Okay. So the same thing I am representing in the form of neural network model. How you see that? You will see that. Here the challenge is to design a neuron to model A dash B dash. So here is the major challenge is what you see that this can be easily modeled using the following. So then you see that A equal to, so let us see here is, this is what you see, A dash B dash. So I want to model. So this is what you see that A is equal to, so how to that? Let us see here. The output of the neuron is, so let us see here is 0.5 plus W1x1 plus W2x2. So this is what the additive function, you know that. Okay, additive function. So now let us see here is, what am I doing here is, for the calculation of the A dash B dash only. Let us see x1, x2 inputs I am taking. A, B means x1, x2. Please let us assume A, B means x1, x2. A is x1, B is x2. So now let us see here is x1, x2, x1 dash and x2 dash. X1 dash and x2 dash is what you see that. So value is 0, 0 means 0 means x dash is 1 and 1. So 1. So next you see that this is 0, 1 and so 0. So then 1, 0. So this is also you see that 0. So all are zeros. So now what I want to do here. So 0.5, this is the active, this is the additive function I'm taking. Additive function, you see that. So additive function, with the help of the additive function, I should get the same value. So what is the actual target is 1, 0, 0, 0. Now am I getting with this additive function values? You see that. Am I getting or not? I have to be checking. So now let us see here is W1 value -1, W2 values -1. But here is bias value 0.5 I have taken. So 0.5 I have taken. So now let us see here is, so I am substituting here the values. So what about this x1 is 0, x1 is 0, 0 multiply -1 plus x2 is 0, 0 multiply -1, 0, 0 plus 0, so 0.5. So this is the value is 0.5. So 0.5 is, now again I have to check with the activation function. What about this threshold value? So whether this condition is true or not, 0.5 less than or equal to 0, the condition is, you see that false. When the condition is false, else y is equal to 1. So this is the A is equal to 1. So this is the formula I applied, 1. Next, similarly I apply for the next input value. So x1 is 0, x2 is 1. So then what about the same formula? X1 is 0, 0 multiply -1, so 0, 1 multiply -1, -1 plus 0.5. So -1 plus 0.5 means if I do this computation, then minus 0.5. Minus 0.5 minus 0.5 less than or equal to 0. So that is what? 0. Let us see. Condition is true, then this is 0. Similarly, you calculate for the next input also. X1 is 1, x2 is 0. So x1 is 1, 1 multiply -1, plus x2 is 0, 0 multiply -1, so 0. So -1 plus 0, -1 plus bias value 0.5. So that is what? Minus 0.5. Minus 0.5 less than or equal to 0. Then condition is true, then y is equal to 0. Okay. Similarly, you see that you apply for this also. 1 multiply -1 plus 1 multiply -1. So -2 plus bias value 0.5. So then -1.5 activation function less than or equal to 0, condition is true. So when the condition is true, 0. So now with my perceptron, so I'm getting these are the values. You see that actual output, actual requirement is, this is what. So am I matching with actual requirement or not? Check it. So if it is matching, then whatever the randomly I have selected the W1, W2 and bias value, these are the right values only. So in this case, I need not be required any updations of the weightage or bias value. So which I selected initially, it was right. Okay. So like that, you have to be calculate, you see that. So for separately. Similarly, how to be calculated for the A plus B also. What is the my case one? You see that A dash and B dash plus A and B. So A and B. Similarly, how to calculate for A and B also. I have been explained only for A dash and B dash. You see that this is the example for A dash and B dash. Similarly, you have to calculate for the A dot, B dot, means A and B. The process is the same. I'm not going to explain that case. So now let us see here. Now that we have modeled the individual components and we can combine them using multiple layer or multi-layer network. Okay. First, let us look at the semantic diagram of that network. You see that. So what are the inputs are there? You may be taking A and B inputs. And then what we require, we want to calculate as per the case one. You see that as per the case one, A dash, B dash plus A dot, B dot. You see that similarly, A dash, B dash and AB. So then you go for the addition of these two. So then exclusion. So here you see that in this case, how many hidden layers are here? Here, two hidden layers are here. So in this case, how many hidden layers are required? One. Whereas in the AND gate, NOT gate, and OR gate, in that case, I used only single layer. But when I want to compute the exclusion OR, I require minimum two hidden layers. So okay, with respect to the expression only. Okay. Now here we can see that in a layer one, we will determine A dash, B dash in the layer one. You see that A dash, B dash and A and B. So in the layer one. In the layer two, what we are doing? OR option. Okay, OR operation. In the layer two, we will take their output and implement on an OR function on top. The final network would look like this. You see that. So this is what the final network. So this is what A1, A2. So A2, A dot B. You see that final network here is how I am doing here. Let us see here. So A dash, let us see here. Simply with a single layer also, I am able to finish this task with the for possible case one. Okay, there is a possibility of the I can use either single layer or two layers also. But in this case, what I am explaining here, how to finish how to complete the task with a single layer only. Let us see. Sorry, with the two layers. Sorry, with the two layers only. Okay. Let us see here A1, A dash and B dash, A2, AB. So okay, let us see here is. So what about this is X1? So X1 means A dash, please. A value, X2 is B. Let us assume. X1 is A, X2 is B. So now let us see here is A1 values. What is the A1 values? So let us see here X1 multiply. Okay, X1 multiply and X2 multiplied weightage value. So this is A1 value, and similarly you calculate the A2 value. So what about A2 value? A dot, B dot. So this is the process we want to consider. Let us see in this example, I'll explain very clearly. If you notice carefully, this is nothing but a combination of the different neurons, which we have already drawn. So that is what exclusion OR is nothing but a combination of the different neurons. So the sequence of neurons, I can say the sequence of neurons. The different outputs represent different units. A1 is equal to, see that A dash, B dash, A3 equal to implements A dot B. That means A and B. So A3 means implements R, which works on A1 and A2. Thus effectively A dash, B dash plus A dot B. The functionality can be verified using the truth table. So this is what you see that the functionality can be verified with the truth table. So A1 is what? A dash, B dash means X1 dash, X2 dash. Similarly, A2 means, so X1 multiply X2. A3 means, you see that it's X1 dash, X2 dash plus X1 multiply X2. So this is what you see that. I think now you can get some intuition into how multi-layers work. You see that. So another possible case. So this is what one possible case. The second possible case, X1 exclusion OR X2. So this is the formula which we have seen in the computer organization. Not of A plus B, A dash, B dash. You see that. Now you see that what are the input values? A value, A dash value, B value, B dash. But actually I have only two input values only. AB. But the two input values I have to convert into the A dash, B dash. That is what is it. Now A dash, B, B dash. So now you see that how I'm doing. This is A plus B. This is A dash plus B dash. Then I do the AND operation. Then I go for the NOT operation. Finally, this is the exclusive NOT operation value. So this is the process we want to apply. This is the process we want to apply. But here in this place, in this layer, I want to take a little caring. So because so I have only two input values, A and B value only. But how do I take that is what I'll be going to explain to you. Let us see here. So this is the process of multi-layer concept. So let us see here. Suppose example, another example I'm taking here. So I'll be going to explain to you one more example. One more example. You see x1 greater than 0 and x2 greater than 0, or you see that, please look into this expression. So how to represent this expression in the form of artificial neural network model? The same expression I'm representing in the form of artificial neural network. Let us see here is. So let us see here is x1, x2 input values. So then what I'm doing here is see that x1 is greater than J value. See that this is one neuron value. So this is what A1 value. Similarly, x2 is greater than 0. Then this is A2 value. So once I have the values of A1 and A2, so then again you see that A1 and A2. Okay. So this is what is that the process of the A1 and A2, not A1 and not A2. That means x1, not x1 and not x2. This is what is that. So this is A1 and A2. So here you see that A1 and A2. And then again A3 and A4. A3 and A4 means you see that OR option, OR operation. So this is what this entire equation, this is x1 is greater than 0 and x2 is greater than 0. This is the neuron. This is the equivalent. And x1, not x1 is greater than 0 and not x2 is greater than 0. So this is what you see that. So bias. So like you see that these two values I am taking and R option. R is what? This is what whole thing is A1. So this A3 value. And the second one, this whole thing is this not value. And A3 or A4. So this is layer 3. Similarly, you see that again multiply 2 minus 1 is there expression. So this is what A5 multiply 2 minus 1. This is layer 4. So total how many layers are used here? Total 4 layers, hidden layers are there with respect to the equation only, with respect to the expression only. You see that with respect to the expression. So layer 1, you see in the layer 1 what I did, what I did, x1 greater than 0, x2 greater than 0. So this is what you see that. And then in the layer 2, what I did is see that this subpart and this subpart I computed. The layer 3, what I did, I applied the R option as per the precedency rule only. As per the precedency rule only, please. In the layer 4, what I did, you see that multiplication and subtraction value. So this is what is. So layer 4. So with respect to the expression, I want to represent in the form of multiple layer network only. So it depends on the expression only. So there should be possibility of the simple expressions and complex expressions also. So please, any more queries relevant to this? Any more queries, please? Any more queries relevant to the single layer and multiple layer? The simple expression I can consider as a single layer. The complex expression I can consider as a multiple layer. So this is what, once we understand the concept of the expression evaluation, the artificial neural network is also very easy to understand. Okay, so where the more than one operation is there in the same expression, then I must be required the more than one hidden layer, no doubt about it. So where it is not required more than one, then there I can introduce the single layer concept only. Okay, so as per the precedency order, operator precedency order is there. With respect to that, I have to go for that is what sequence of neurons. Okay. Any doubts, please, relevant to today's topic and yesterday topic, my dear participants?
Yeah, good morning, my dear participants. Please interact because no doubt that this topic will be very much useful for the people who are in this direction. Will be very much useful for our research.
So Janardhan, please, shall we go for the polling?
Yes, sir. Yes, sir. Yes, sir.
So we'll be going for the polling option. Okay. So we may be asking only 3 or 5 questions, 3 to 5 questions. Is relevant to the yesterday and today's session.
Yeah, 5 questions are there in poll 1.
Okay, thank you.
Yeah, yes, I am launching. Yeah, my dear participants, please all of you try to participate in this poll and try to answer this.
Inform to participants, Janardhan sir.
Yes, sir.
Once
Yes.
again.
My dear participants, please all of you participate in the poll. Here we have 5 questions. For every question, we have 4 options, multiple choice. You can choose any one option which you feel correct. Okay. Don't feel whether it is correct or not. Just you try to give your possible good answers. Then sir will discuss the analysis about these questions, because participation is very, very important in the first step. Then second step onwards, the correct answers, and then perfection. Make it fast. 3 out of 40 have answered. Yes, 6 out of 40, 15%. Yes. Come on, my dear participants.
Please select the more relevant answer only, not approximate answer, please, all of you.
Dear participants, please, you try to answer as of now. Out of 41 participants, 18 participants have been answered. Nineteen out of 41, 48%. Yes, 20 out of 41. Out of 41. Dear participants, it is at 20 only.
Okay, Janardhan, shall we go for the discussion?
Yes, sir. Yes, sir.
So artificial neural network used for, this is what in yesterday's session I have given little information. Deep learning techniques can be a supervisor learning or unsupervised learning or reinforcement also. When it is applicable to that, you see that classification and clustering is also right answer. And also artificial neural network in general, I'll use for the computer vision technique, means image processing or video processing or any other. So all these three are right. So when all these three are right, then D is the right answer. So D is the right answer. Okay.
And
So all are
95% have answered, sir.
yes. Thank you. And the second one is back propagation. So technique. So when I should go for the adjustment of the weightages, is if I should not reach my target. So when I should know that I should not reach my target or the output layer only. Output layer means you see that is what sink. So output layer. So again, I have to go to the source. So I have to go to the source. There I have to try to find which is a more influencing input value. So that I have to be selected, that I have to be updated. So the right answer is B. So backward from sink to source. Sink to source, please. This is what. The next answer is, here is I have given wantedly 4 options like a similarly. See that an artificial neuron receives n inputs. But here is how many inputs I have specified very clearly. I have specified. Sorry, this is what have been represented wrongly. That I have to provide this 2 only. But even though n, how many inputs I provided here? X1, X2. No, and so on, Xn. So that only 2 inputs I have given with weights W1 and W2. So attach it to the input connections. The weighted sum is what? How many inputs are here? Only 2 inputs I have specified. I have not specified X1, X2 and so on, Xn. So when I have the 2 inputs, then definitely my weighted function is X1 multiply W1 plus X2 multiply W2. So this is what little confusing is there, but which is the more relevant answer? Right answer is W1 X1 plus W2 X2. So third one is right answer. But the summation, what is the need of? Again, summation, no need of this. Because of here only 2 inputs are there. Okay, so this is what. Next, fourth answer. What is the back propagation? You see that the back propagation, it is another name given to this is not the right answer, no doubt. It is the transmission of error back through the network to adjust the inputs. So not for the, again, transmission of the error. It is the transmission of error back through the network to allow weights to be adjusted so that the network can learn. So mainly for what purpose? For adjustment of the weights only. Okay. So right answer is C. So right answer is C, please. Okay. Forward artificial neural network information flow is. So just now today in the today's session, I told very initially the feed forward network is unidirectional only, not bidirection, not multi-direction. Okay, so when these two are not valid, then only answer is unidirectional. Okay, so unidirectional. So thank you, Janardhan.
Hello, sir.
Yeah, shall we continue?
Yes, sir. Yes, sir. Sir, end polling.
Yes.
This is the result, sir. People have majority of members have answered like this.
Yeah, please. So result I have been shared. Now you want to? Would you like to show the result?
See, whoever have answered more, that is it's a different color. Just only for the participants' information sake, sir. Yeah. Shall I close this one?
Yeah, please.
Yes. Yes, sir.
So shall I continue, Janardhan, please?
Yes, sir.
Okay.
Sir, probably by 11:10, hope this session will be.
Yeah, definitely. I'll just give the brief information. It is more important who are working for the research. Okay. I'll close it within 15-20 minutes. Thank you. Tasks neural networks perform: classification, prediction, clustering, associating, etc. So this is what yesterday. So this is you see that I think who are very much interested to work for the research, the future enhancement of fingerprint recognition system. Okay, Instead of the fingerprint, you can take it iris or maybe any other object also. Okay, future enhancement of iris recognition system, future enhancement of the object recognition system, future enhancement of the computer recognition system, whatever it is. So this may be changing. So various objects are there. So now just I'm giving the brief information. In this process, what are the steps are required? So now I have classified into 4 steps. You can divide as maximum as possible as you wish. But as per my requirement, I have been considered only 4 steps. Step 1 is first image acquisition. Next, second step is pre-processing. Third step is feature extraction. Fourth one is matching. So in this, I think you are very familiar, image acquisition. And once I receive the image, that image I have to be pre-processed. Why should I pre-process? Means some noisy data may be there, some background may be different shades might be there. Such things I have to be removed and I have to be extract exact image which I want to process. For that purpose, I want to apply the pre-processing. Once I have the image, on that image, I have to try to find the features. So without identifying the features, then I should not be able to go for the matching. You see, this is what the process. In this process, I'm applying the deep learning techniques, which is a method is that is autoencoder. So you know that there are various methods are there in the deep learning, but in the deep learning, I have selected only autoencoder. This is the work is doing by my research scholar. So I'm not going to share everything, just very brief information I'm going to share. Still they are working for the research. So that due to that, I should not able to share everything. Deep learning techniques are incorporated in the proposed research work to achieve the main 2 parameters like what is the purpose of deep learning techniques mainly I'm taking here is recognition accuracy. So recognition accuracy means sometimes I used to say approximately is like a junior NTR, approximately is like a junior say Balakrishna. Like they used to talk about that, not approximately. So I should say straight away, oh, he looks like a Balakrishna, he looks like a Nagarjuna. Like I should able to justify that, not approximate or something. So as much as possible, try to improve the accuracy of the multimodal biometrics and revocability of stored biometric fusion templates. Okay, fusion is concept is the combination of several things. And autoencoder. What is autoencoder? Autoencoder is an unsupervised artificial neural network used to learn a compressed representation for a set of data. Autoencoder is employed on the image for robust features extraction, enhances the accuracy, and mitigates the reconstruction error. It is good enough for deeper representation and reconstruction of image data. It reduces the dimensionality. So this is what first I need to understand the method, where I can apply, when can I apply, how should I apply. So I'm not going to express much about this information just. So working of autoencoders. So the working of autoencoders. I must know the autoencoder working process. Autoencoder is applied on the image of deeper representation of the image. So input layer, hidden layer, output layer. In general, you know that in the artificial neural network, there are 3 different layers are available. One is input layer, hidden layer, output layer. Now let us see how I'm using the autoencoder. The larger representation of an image is taken into smaller representations. So generally the image is very large, that I'm making into the smaller representations. We divide it into several subpieces, I1, I2, I3 and so on. Because of when I take it as it is image processing is required a lot of amount of time. So as a single image, I could not able to process sometimes. So that what I'm doing here, I can divide as maximum as possible subdivisions. Then in hidden layer, the encoded image is generated here, which helps in the dimensionality reduction. So this is what is that dimensionality reduction I have been already shared with you in the hidden layer. I'll give the one example also, easy to understand. So this is what the formula already available. Better to go back to the literature. And then output layer. Output layer is this is what is that function. The output is the reconstructed input is formed by the, this is what y equal to bi f of function. This is what additive function already. You see the same thing, hidden layer. That's with the help of this, I'm taking the decision O1, O2, O3 and so on, working of autoencoder. So this is the process of the autoencoder working. Input layer, hidden layer and output layer. So now how to apply this is the method you see that for that. So let us assume image acquisition. Consider a gray color image of size 5 by 5. So let us take it. I am taking the image. So image, I think you know that we can represent in the form of numerical values. You know that this is what pixel values. So the image I am taking size is 5 by 5 size only. So maybe you can take 10 by 10. For understanding purpose here, I have taken very small size only, 5 by 5. These are the values are representing what pixel values of the gray color image. So the acquired image is sent to the pre-processing stage for the denoising the data. So this is what acquired image. So I think you are all very familiar image processing techniques. Okay. So image maybe storing in the form of like this only in the memory. Pre-processing stage. The processing of the gray color image include two images. One is a binarization and a thinning method. So there are two different methods are there, binarization method and thinning method. What is mean by binarization? Convert the input image into the binary image. What I have that this is what a gray color image. This is a gray color image, RGB. This represents the RGB number. You see that 250, 230, 180. But this image I am converting into the binary image. So that means black and white image. That you know that this is what gray color image. The same image I am converting into the with the help of the binarization into the binary image. Binary means white and black. Convert the input image into binary image using Benson method is a Benson is a local binarization method which computes the threshold value from fixed of range. So you see what I'm doing here in this set, which is the lowest value, which is the highest value, the two values I'm selecting. So that means n low plus n high divided by 2, average I'm taking. So that average value I'm using as a, you see that low value is a 90, high value is 250 is there. You have to search in this low value is to select and high value. Sorry, here is 85 is there in this example. So I want to select the 85 only, but by mistake, okay, 90 I have selected. Okay, so until I did in the presentation, because of someone can point out, or maybe I also can correct it. So n low equal to 9. Actually, 85 is there in the table, but here I have selected 90. But actually, I have to select 85 only, please. So low 90 plus 250. So then what about you see that 170? So 170 is the threshold value. Now this is what if threshold value is greater than pixel value 1, otherwise 0. So let us see here is 170. Above, what are the 170 above? So this, so you see that 11 value, 12 value, 13 value, 14 value. So like you see that all these are ones. This is what 0. Like this you have to represent. You see that so 170. Okay. Let us see here is 170, 120. So this is what you see that 1 1. So here also actually I have to keep 1 only. Why means this is 170. This is 170 means here you see that 180 is there. So how it is possible 0? So that I have to be keep here 1 only. 1 1 1 till I have taken wrong information for sharing with you only. So 1 1 1 0 1. Like this you have to be fill all the remaining values. So then this is what binary image. Binarization helps to convert a grayscale image into black and white images. So this is what binarization method is very easy for conversion into the black and white. So these are the binarization. Next, thinning method is there. So I'm not going to explain much about this. Please okay, try to understand. Time constraint is there. I want to share much regarding the artificial neural network model. So this is part of the pre-processing only. Binarization, thinning, the both are the part of the pre-processing level only. So there are certain methods are there. Okay, this is a lengthy process. Please, it takes around 1 hour time for explaining of this concept and previous one also. Okay, like this, you do the pre-processing. Once, what about image? What are the steps are required? Image acquisition, pre-processing, feature extraction, matching. Now what we did, image acquisition over and pre-processing completed. Now we are in the feature extraction. What is meant by feature extraction? You see that here. The step 3 is a feature extraction. In this proposed method, we are extracting rich endings and rich bifurcations from the binary image of fingerprint. In the pre-processing level, have been converted into the binary image. From the binary image, what I am trying to finding rich endings, rich bifurcations. So this is what you know that ridge ending means, like a ending lines you might be seen in the finger. In the finger, certain lines may be there. In the lines, maybe that means either it may be spiral, or it may be a dead end, or maybe like a bifurcation means like a tree, or left and right direction. So this is what you might be. You can see a lot of things in the finger. Where you go back and please look into your finger. In that you can find ridge endings and ridge bifurcations also. Consider each 3 by 3 part from the pre-processed image and apply cross number algorithm. So now this is what you see, that cross number algorithm is there. So this is what we want to select, taken from the pre-processed image. So this is what pre-processed image have taken. And this is what, using the cross number of algorithm properties, if the output is as follows, this is what cross number. Okay, so this is what you see, that 100, this is image I have taken with the pre-processing level. Then you need to apply, this is the method, you see that Cn is equal to. So these are the features are there already, properties. These properties are defined by some author. I have selected from the literature only. So you must know what are the properties. Cn value, if it is a 0, then this is isolated point. Cn value, if it is 1, then this is a ridge ending point. Cn value is 2, continuous ridge point. Cn value 3, bifurcation point. 4 is a crossing point. So in our finger, you check, these are the possible properties are there. Isolated point, maybe you can see in the finger, or you can see ridge ending point also. You can see continuous ridge point. You can see the bifurcation, some maybe like a root and left and right, and crossing lines also may be there in the finger. These are the properties I might be considered from the literature. Now cross number algorithm. This is the cross number algorithm formula. So this is what 0.5 multiply summation is equal to I is equal to 1 to n pi minus pi plus 1. So this is what you see, that pi means you start from somewhere. You start from somewhere. Suppose if I start here pi, and this is what pi plus 1. So, okay, pi plus 1. Like you calculate 1 minus 1. So this is what 0. 1 minus 0. This is modular. So that 1. So this is what, once again I'm repeating, please. This value how I can achieve means 1 minus 1 as per the formula pi minus pi plus 1. So this is pi. This is pi plus 1. This is pi plus 1. 1 second, please. Okay, pi minus pi plus 1. So this is pi value. This is pi plus 1. 1 minus 1, 0. Similarly, you calculate rotation method. 1 minus 0, 1 minus 0, 1. So 0 minus 0, 0. 0 minus 1, 1. 1 minus 1, 0. 1 minus 1, 0. 1 minus 0, 1. So based on this formula, please, pi minus p plus 1. So next, 0 minus 1, 1. So like this, I calculate the values. Then you apply the summation of all this. You see that summation of all this. 1 plus 0, you see that 1 plus 0, 1. Plus 0 plus 1, 2. Plus 0, 2. Plus 1, 3. Plus 0, 4. Plus 0, 5. Sorry, 4. 3, 3. Plus 0, 3. Plus 1, 4. So total 4. You see how many ones are here? That is what indicating total 4. So 0.4 multiply 4 equal to 2. If the values are looks like this in the image, then this is one property. What is that property? Cn is equal to 2. So 2 means this is what continuous ridge point. So if the values are like this in the image, then this is equivalent to the continuous ridge point. Like you see that all images, suppose that maybe get 3 or 1 or 0 or 4 also. So this is what, like a continuous ridge point. These are the values. This image looks like a continuous ridge point. This is what you see, that crossing ridge point. How to decide this is the crossing or continuous point means based on the Cn algorithm. Cross number method. Cross number. This is defined by some ex-author now collected from the literature. Next, ridge ending point. Like finally, you see that this is a very lengthy process. I'm not going to share much, please. Consider only ridge ending and ridge bifurcation features and fuse them in a future level. So now what I decided, I can combine two features. What are the features I am taking here? Ridge ending and ridge bifurcation. So ridge ending is, these are the values. 111, 001, 000. Okay, this is values. And ridge bifurcation values are, you see that ridge bifurcation. Where is the ridge bifurcation? You see that continuous. This is bifurcation point. So these are the ridge bifurcation point values. Now, when I want to fusion these two features means these values here you see that, and bifurcation point value 0, 1, 0, 1, 1, 1, 1, 0, 1, 0. You see that? So this is the, I'm doing this. This is one of the best method for fusion purpose. So you can go for the fusioning of the method is either cross pointing and a continuous ridge also. You can combine and you can do the process. But here I have considered bifurcation point and ridge ending point. So B union C. Okay, this is what fused image. This is fused image. So maybe people are getting sometimes doubt. Sir, fusion means what? Fusion means it is a combination. It is a combining of 2, 3 features only. 2 or more features also. You can combine. Now feature enhancement using encoder. Now let us see. This is the fused image. Now I want to identify the features from this. What are the feature enhancement using autoencoder? How do I enhance the feature in this input layer? So what is this finally? This is what input layer. This is what input layer for artificial neural network. You see, up to this, my artificial neural network model is not playing any role. First, image acquisition, next, pre-processing, next, fusion. So once fusion image is there, now I am taking this image, this you consider as an image, binary image, taking as an input. So this is what input layer. Actually, as per the artificial neural network, there are 3 different layers are there. Input layer, hidden layer, output layer. So now this input I am taking as an input layer data. In the input layer, how many are here? You see the count it. How many rows are here? How many columns are here? 3 multiply 6 are there. So total dimension, what is the input image with the dimension of 3 multiply 6? Consists of, you see that, how many input values are here? 18 input values are here. 18 input values are here. So now we have considered, so do you want to go for the 3 hidden layers or 4 hidden layers or 5 hidden layers? That is what you decide. So then you see that here, I decided we have considered 4 hidden layers. It requires 72. So 4 hidden layers multiply 18 input values, random weights. So as per this example, consider 6 values as the input to the hidden layer. So here is what about, you see that each row is consisting of how many input values? How many input values? 6 are there. So 6 values I am taking as the input to the hidden layer and requires 24 random values. So why it is a 24 is required? You see that. Let us see here. 24 random values are required. So this is the process of 6 values. Totally 6 values. And how it is possible hidden layer and require 24 random values? How it is possible? Total how many hidden layers are there? 4 hidden layers are there. 4 hidden layers are there. How many input values are there? 6. So 6 multiply 4, 24 random weights values are required. Let us see hidden input values x1, x2, x3, x4, x5, x6. So then what about you see that 4 nodes in the hidden layer? Node 1, node 2, node 3, node 4, node 5. You see that like this, node 4. So then you take it all these, how many total number of, okay, random values are required. So 24 random values are required with respect to the input values only, and also with respect to the number of hidden layers. This is the process of that. The hidden layer calculation represents as follows. Hidden layer output, hidden layer output. Let us say this is what autoencoder, which we discussed earlier. So better to go through the literature, please. This is what. So WIXI plus BJ. So this is what the formula additive function, you know that already. So this I am applying. These are the weightage values, random weightage values. These are the random weightage values. How do I select the random weightage values? You see that input layer weights. So the first three are weightages of inputs. Last one is bias value. So why here it's four rows are here? You see that in the input image, 3 rows are here. In the input layer weightage, 4 rows are here. The last row is indicating the bias values for each hidden layer. So this is what the process of, you see that f of x is equal to 1 by n summation I is equal to 0 to n. So this is the formula you need to apply, 1 by n. What is the WI is input weight vector, XI is input fingerprint pixel value, PJ is input bias value, number of hidden neurons, N is a number of hidden neurons. Hidden neurons, you see that total number of neurons. So with the help of this, you see that now how to calculate H1 equal to H2 equal to H3 equal to H4 equal to. So total how many you see that here is, so H1 equal to H2 equal to H4. So now this is what you see that H1 equal to 0 multiplied 0, 9, 1 multiplied 0.07. Like you see that all these values, this is value. You see that how many inputs are there? 1, 2, 3, 4, 5, 6. So 6. Oh, you see, let us here. So what about 0.09 multiply with input value? 0. Similarly, 0.07 multiply with 1. So plus 0.05 plus 1. You see that 0.01, 0.1, 0.1 multiply with 1. Similarly, 0.5 multiply 1. This is the process we need to go ahead. So that is what here you see that same process. H1 value we may getting 0.42. H2 value also similarly. What is the H2 value? Similarly, you see that H2 value similarly 0.01 second row multiply with the second row of the input values. Okay, same thing. So this is what H3, H4 like it. We calculate for all the values. Finally, we may be achieving 0.42, 0.54, 0.55. Okay. So this is the way we have to be calculate the hidden layer output. So this output I have to use it for the matching. Next level is matching. So that is a little complex process. I'm not going to explain to you. So like this, you have to be identify the first how many hidden layers are there, you decide, and how many neurons are required. That is with respect to the input values and hidden layers only. So this is very complex job. How to select the, how to identify the number of neurons, how to identify the number of hidden layers. With respect to the input value, first you define how many hidden layers are required. Based on that, you can decide how many random weights are required. Random weights are depends on the number of hidden layer neurons and input values only. Input values and hidden layer neurons. So thank you, one and all. So Janardhan, please.
Yes, sir.
Yeah, please.
Sir.
So any more queries, please?
Participants. Sir, we have.
Hello, sir.
Yeah, please, sir.
Sir, how do we calculate entropy for that all given values, sir?
No, that is what another function is there, sir. Please, sir, that I have not been explained to you.
Okay, okay, sir. Okay.
So
Sir.
because of it takes another half an hour minimum, 1 hour. So
okay.
just I have given the information how to identify the number of weightage values. So how to identify the number of weightage values with respect to the input values and the number of hidden neurons only. So number of inputs multiply number of hidden neurons is equal to number of weightage values.
Okay, okay, sir. Thank you, sir.
This is a very lengthy process, sir, actually. I must be required minimum 3 hours for a.
Yes, sir. Yes, sir. Yes. Thank you, sir.
Thank you.
Hello, sir.
Yeah, please, sir.
Sir, we have poll 2, just 2 minutes. Shall we give to the participants, sir?
Okay, okay. Thank you.
Yeah, my dear participants, poll 2 is in progress now. Just you try to answer for this poll 2. Only 5 questions, 2.5 minutes. Sir, general thing. ఫస్ట్ మీరు ఎట్లా వచ్చింది? Yeah, 20 out of 39 participants have answered.
Yeah. The fundamental unit of network is, so we are talking about the artificial neural network. In the artificial neural network, which is the playing the key role? A brain, a nucleus, a neuron, or axon. Remaining all relevant to the human, but the neuron is what? Relevant to the artificial neural. So this is which is the right answer? Means C is the right answer. Next, the process of adjusting the weight is known as learning only. So for what purpose? Weightage change means learning. So today I prepared a curry, but the taste is different, like salt is more. So then what I have to do? I have to go for the readjustment of the weightage. That is for what purpose? Learning only. Next, what does the character B represents in the additive function? So we are talking about here is artificial neural network. So we always use the word is that is what? Weightage and bias only. So that B represent the bias only. Maybe in the y is equal to mx plus c, in that case the c may be a constant value, but we are talking about the artificial neural network only. So where we are, that is very much important. In that domain, we have to be identify relevant answer, more relevant answer. The bias is not there, then I think it could be reasonable answer, but bias is there, so bias is the right answer. What are the steps for using gradient descent algorithm? So first one is what you see that missing content is there. Janardhan sir, please. Janardhan sir, content is maybe missing. Okay, that is the last answer only. Content is missing first. Okay. What is a perceptron? What is a perceptron? A perceptron is a single layer feed forward neural network with a pre-processing only. Okay. So please show the answers, Janardhan.
Sir. 1 second.
The fourth question, content missing.
Yeah. Okay. I will share, sir. I will share afterwards in the group.
Okay. Thank you.
Fourth one is missing.
Fourth one only, content missing. Okay.
Yes, I will share as it is in the WhatsApp group, sir.
Okay. So,
Thank you, sir. Thank you very much for your valuable time with us. Today is the second session. It's a really very great session. Hope every participant might have utilized to the possible extent in their research area. We have shown the artificial neural networks with real-time examples.
Excuse me, sir.
Yeah. Any more queries, please?
Yeah, my dear participants.
Sir, excuse me, sir. Cross number algorithm, can you explain, sir?
Sir,
Which
sir,
one?
may I know?
Cross number. Sir, cross number you want. One second. This is what cross number. Okay. Okay. This is what you want, no? Please, my slide is visible.
Yes, sir.
My slide, Janardhan, sir.
Yes, sir. Yes, sir.
Okay. Using the cross number properties. So this is the, let us assume this is the image 3x3 size. Okay. So this image, total how many are here? Then 1 1 0 0 1 0 1 1 1 1. Okay. Now cross number formula is Cn equal to 0.5. Summation of I is equal to 1 n modular of pi minus pi plus 1. So in this, what I am doing here, you can start from anywhere in the rotation method. This is the rotational method. Rotational method means you see that 1 minus 1 0 plus 1 minus 0, okay, plus 0 minus 0 plus 0 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus 0 plus 0 minus 1 plus 0 minus, sorry, 1 minus 1. So this is the value of this 4. So you got my point, please? Once again, I'm repeating, sir. You look into this picture. This is what? A binary image. In this binary image, how I'm getting these are the values? 1 minus 1, 0. 1 minus 0, 1. This is the value, please. See, look into the cursor, please. 0 minus 0, 0. 0 minus 1, 1. So this is what you see that for either negative or positive, finally I'm considering as a positive only. So 1 minus 1, 0. 1 minus 1, 0. 1 minus 0, 1. 0 minus 1, 1. So finally, what is the summation? I is equal to n. So summation means 1 plus 0 plus 1 plus 0 plus 1 plus 0 plus 0 plus 1. So finally, what is the value here? 4. So 4 0.5 multiply 4. 0.5 multiply 4. This is 2. So when it is n is a 2, then this image looks like a continuous ridge point. Okay. Here you see that Cn values 0, 1, 2, 3, 4. Okay. So thank you. So
Thank you very much, sir. Thank you, sir.
Clear my doubt? Your doubt, please.
Yes, sir. Cleared, sir. Thank you, sir.
Thank you. Thank you. Any more doubts, please?
Sir, thank you very much for your very important session, which is very much useful to all the participants. My dear participants, still if you have any queries, you are most welcome to post the questions either in the chat box or even we have a mail or even in the group also. In turn, I will forward the questions to our resource person, Dr. S. Viswanadha garu, so that we'll get back the answers for you. Okay.
So,
thank you, sir. Thank you very much for your valuable lecture with us. Now I request Madam Radhika.
Yeah. Please. 1 second, Janardhan.
Yes, sir. Please, sir.
Yeah. Thank you very much for providing opportunity to interact with eminent personalities. I'm really very happy. So maybe the second topic may be required minimum 3-4 hours, so that I have given briefly. That work is also my student work, so I should not able to give 100% of information. And also, I'm very much thankful to for the interaction with me. And finally, I would like to say that thanks to your management, your coordinators, your organizing team, and not least, finally, I would like to special thanks to Janardhan garu. Thank you very much. Thank you. And please, if you have any doubts, you can
Sir, small
share with my
submission.
mail ID or WhatsApp number.
Small submission, sir.
Yeah, please. Please.
Sir, good morning, sir. I am Dr. Devinder, Polymer Engineering College, sir. Since
please,
2002, I am watching you, sir. We called you as a guest to the IIIT Engineering College, Siddipeta for the DA lecture, sir. That day you are given very good lecture, sir. At that time, we don't know how to teach the even DA subject. Being a DA faculty, I called you, sir. So you taught that time very well. Since that time, I'm remembering you. I'm every time watching you, sir. Your growth is really it goes very exponentially, sir. I'm very happy to.
Yeah. So, thank you very much, my dear. Thank you very much, sir. So, for your observation and for your feedback.
You are always an example to the learners, sir. Junior faculty.
So, thank you. Thank you.
Thank you, sir. Thank you, sir. Thanks a lot, sir.
Yeah. Thank you, sir. Thank you very much. Now I request our Madam Radhika to provide a vote of thanks for this session. My dear participants, please be in line even after this immediate session. Now, next session will be by Professor A.J. Ramakrishnan Garu, who is a professor from Indian Institute of Science, Bangalore. Next session. Please be in line after this vote of thanks of this session. Madam Radhika, please proceed.
Good morning, one and all. It's my privilege to propose vote of thanks on day 4, session 1 for 1 week online ISTE-STTP on machine learning applications, research challenges 2020. I would like to extend special thanks to Professor Viswanadha Raju Garu for sharing enlightening knowledge on artificial neural networks with real-time examples part 2. In continuation with yesterday's discussion, Sir has given a brief explanation regarding logic gates such as AND, OR, NOR, and so on. And similarly, single dimensional and multi-dimensional artificial neural networks, which helps us very lot for the starters or else for the research scholars who are looking about to have a research in that area. And a special thanks, sir, for providing us a good demonstrative knowledge on feature enhancement of fingerprint recognition system, which is going on. And I think each and every participant have gained a good knowledge regarding this, and everybody will have research in that in the future, sir. Thanks a lot for providing us a very informative session, sir. Thank you.
Thank you, madam.
Thank you, sir. Thank you very much.
Thank you very much.
Thank you, sir. Thank you.
Shall I leave, please, Jonathan, sir?
Yes, sir. Please, sir. Yes, sir. Yes, sir.
Thank you.
Thank you, sir. Thank you very much. My dear participants, be in line. Good morning, sir.
Very good morning.
Warm welcome, sir, to our session.
So how many participants are there and what is the nature of the participant background?
Yes, sir. Actually, 84 participants have registered, sir.
Okay.
Now, in live, 44 participants are there, sir. Almost 80% of faculty are from CSE background, sir.
Okay.
Most of them are faculty ones. All are faculty only.
All are faculty only. Okay.
Yes, sir.
You have not invited your college students?
Maybe 5-6 members they have joined, sir, because examinations are going on here. Examinations.
I understand. Okay.
That's what, sir. In fact, we have extended this opportunity to all the members across the nation, sir. Sir, shall I start to introduce, sir?
Yeah, please go ahead.
Respected today's resource person, Dr. A.J. Ramakrishnan Garu, who is Professor, Indian Institute of Science, Bangalore. It's my privilege to introduce about today's great personality, presently who is working as professor at Indian Institute of Science, Bangalore, in the Department of Electrical and Electronics Engineering. Professor has completed his PhD from IIT Madras in 1989, MTech from IIT Madras in 1982, BE Honors University of Madras in 1980. Number of awards are in sir's credit. To name few of them are Fellow Indian National Academy of Engineering in 2019, invited member of Senate, IIIT Allahabad, Prayagraj, February 2019, member of Karnataka Knowledge Commission, August 2017, Jaya Jayant Award for Teaching Excellence in Engineering by IAC Council 2016, Manthan Award, South Asia and Asia Pacific E-Education category 2015. Again in 2014 also, Professor M. Krishna Award by International Forum for Information Technology for Tamil Internet 2013, Vice President Indian Unit for Pattern Recognition and Artificial Intelligence, President Biomedical Engineering Society of India 2001-2008. Young Investigator Grant by Department of Science and Technology, Government of India 1994. Sir Andrew Watt K. Young Researchers Prize from Royal College of Physicians and Surgeons, Glasgow 1992. Thangam Vasudevan Award, Indian Association of Biomedical Scientists 1986. Associate Editor, Sadhana, Member Governing Council, Siddhaganga Institute of Technology, Tumkuru. Member Board of Studies, International School of Information Management, University of Mysore. Like this, majority of awards are there and even other credits. Professor has patents in his credit. Method and system for enhancing binary document image quality for improving readability and OCR performance. And again on a method to extract and align text of an image captured and a system thereof. And one more patent on attention feedback based robust segmentation of online handwritten course. Under his able guidance, very good number of PhDs have been awarded and even number of PhD scholars are pursuing. Just a few words more. Sir has graduated 31 research students. He received Manthan Awards in 2014 and 15 for social impact of his work on OCR and text-to-speech in Indian languages. Blind students are using over 600 Braille books in Tamil and Kannada, converted from printed books using his OCR. He has developed unrestricted vocabulary, handwritten word recognition systems for Tamil and Kannada. He proposed a new algorithm for pitch modification using DCT in the source domain. He has also developed Thirukal and Madhura Ochaka TTS for Tamil and Kannada used for blind students, for which he received the Manthan Award 2015 in the education category. He conceived of Linguistic Data Consortium for Indian Languages, currently managed by CIIL, Mysore. He was a member of Karnataka Language Commission and FICCI, Indian Language Internet Alliance. For his earlier work on nerve condition in leprosy, he received the Sir Andrew Watt K. Young Researchers Award from the Royal College of Physicians and Surgeons, Glasgow. And he was the President of Biomedical Engineering Society of India, Vice President of Indian Unit for Pattern Recognition and Artificial Intelligence, and he is a Fellow of Indian National Academy of Engineering. In fact, it's a really very great opportunity, and it's a very great opportunity to once again to all of us to have the grace presence of you, sir, for your immediate acceptance and sparing your valuable time with us with this little bit introduction. It's a really warm welcome to you, sir, to our session today, sir. Thank you, sir. Thank you very much.
Very good morning to all of you. Is my slides visible?
Yes, sir.
Okay. So, thanks for the introduction. My dear faculty colleagues, actually I had sent a very short introduction only. So, but Professor Janardhan Raju must have picked up something else from my website or something. So he made it longer. Anyway, so the topic today is hard-coded features in the brain and deep neural networks. So what I'm trying to get here, I generally believe that in a short course of few days, you cannot learn, because all of you are teachers, you know that any one subject you teach over a entire semester, and where students also do a lot of assignments and so on. And without that, there is no real learning takes place. So what we can really do in a short talk like this is to inspire and leave the people inspired, so that if they are really interested, they should go back and start really learning. So that is my approach to any such short talks. I don't get into very details, mathematics and so on. That has to be, on a different this thing, where if we have a long-term presentation over a few days, we can try that. And before I get into this topic, the topic here, basically what I'm looking at is, see, in the deep neural networks, you must have heard of this everywhere. And the current belief is what they call end-to-end networks. So they feel that everything the neural network has to do, from feature extraction to classification, whatever you want to do, it has to do. They think that brain also does that, and many people justify that. But what I want to establish here is that it is not the way the brain is doing. Brain actually does a lot of feature extraction, and it has evolved over time. Not only human beings, but even animals extract a lot of features. So it's a combination of the carefully chosen feature extraction plus the computation in terms of neural networks, which is able to accomplish the good performance of the brain as a great visual recognition system. And I think it will be wrong if you think that we assume everything has to be done by the network. We have a lot to gain by the current knowledge which is already known in signal processing or image processing or natural language processing, and then apply it along with deep neural networks. So before going that, since you're all faculty and you will have, some of you may be doing currently PhD, some of you may be having PhD students. So I want to talk a little bit about what is the context of research, and why many of the research in India is not really taking us to fruition. So I want to define this term called context is decisive. That is, whatever context is something you might have distinguished or you may not have distinguished, but it is there deep inside your mind with your knowledge or without even your knowledge, and that is driving your actions, and that is giving rise to whatever result. If you have great results, that is because of your context. If you don't have great results, that is again because of your context. So you need to really distinguish what is the context that is driving your actions, whether it is in research or even elsewhere in your life, especially in relationships and so on. So whether a human being or an organization, we need to have a vision for our life or the vision for the life of the organization. I want to give two examples. One is the public sector labs, which are started by public sector organization started by Nehru, and ISRO, which is started by Satish Dhawan. So in ISRO, if you look at their website and see what is their vision, why they created ISRO, they are clearly saying harness space technology for national development while pursuing space science research and planetary. I don't know whether you can know this. Yeah, okay. While pursuing space science research and planetary exploration. So they made it very clear that while they are interested in research and planetary exploration, they want to use that for national development. And you know how much ISRO has helped us in terms of our national development. We have so many channels in TV. We have so many educational channels. We have NPTEL is also coming through the TV channel. There are so many things in terms of education. Of course, the TV channels are also misused, but we cannot blame ISRO for that. So they have contributed extraordinarily in terms of contribution to the nation through the technology. And let us look at what is the vision that Nehru created for the public sector enterprises. He said, create infrastructure, absorb technology. They didn't say create extraordinary world-class technology. They said absorb technology. That means already which is there, you just absorb, and create infrastructure, which means some land and buildings. encourage innovation. I'm happy at least something was there. Generate employment and achieve certain social objectives. See, if you look at the Japanese industries, they have a vision of zero defect policy. So when an industry starts, they say the way we create products, there should be zero defects. That's why, you know, most of us use the electronic equipment made by Japan, or cars made by this thing. And even in US, they buy Japanese cars as some other cars rather than the General Motors cars or Ford cars from US. So here, the vision was very limited. They said, let us generate employment, let us create infrastructure. So you can see that all the public sector created huge land mass. You know, I'm in Bangalore. If you see, you go to BEL, there is a very, very big land. BHEL labs in Hyderabad, you can see a lot of land, lot of buildings, lot of employment. In my times, you know, when I finished BE, every year, all these public sectors will have an exam and take 50 engineers. They call management trainee. Whether they had actually a job for them or not, I don't know. Every year they used to take 50. So they used to generate employment. So it's very important what your vision is, because that will drive what you actually achieve personally also. So that is what I call context. The context is nothing but the vision which you have either consciously created or unconsciously it is there. So that is what I'm saying. Either there is a created context, or if you have not explicitly created, even then there is a hidden undistinguished context. Another example, if you take, see, Narendra Modi is just an arts graduate. I'm not a BJP man. I'm just pointing you to something. He's just an arts graduate. However, his created context for his life has made him the prime minister. See the kinds of demands made on this arts graduate. He's not even an engineer or doctor or, you know, architect, nothing. But everybody expects him. Anything goes wrong, they say he has not turned around the economy. He has to turn around the economy. They expect him to make India a powerful country. They expect him to improve the laws. They expect him to improve technology. They expect him to bring better peace with other countries and so on. So all of that demands makes him whatever he is, and that is because of the context he created for himself. So the context for my lab, our lab is called Medical Intelligence and Language Engineering Lab. The context is research with real life applications while creating technology leaders for the country. So our research is always focused on real life application. I don't want to just publish papers. I want that technology development which goes to practical use. But in the process, of course, our job in an educational institution is to create students, train them. So we are also training the students as technology leaders for the country. And we have always collected data from the field. So one thing we don't believe in is downloading data or code, because India has 1/6 of the world population, and we have much less restriction in terms of data collection compared to US or some other country. And our people are all very friendly. So whatever data you want, you can easily collect. But again, you know, you must come from it is possible in the context. We have collected, you know, compound nerve action potential, evoke potential from leprosy patients, from 2000 plus ultrasound images from Indian, Malay, and Chinese population. We have collected ultrasound images for our research. From NIMANS, which is a mental health organization, we have collected MRI data. We have collected blood cell images from a hospital in Kaiserslautern in Germany. We have collected more than 28,000 word images for script recognition in 11 languages. More than 15,000 plus document images, that is each page of a book scanned. So 15,000 such pages, and also camera captured images. And all of this are also annotated in terms of, you know, what is the text is available, multiply corrected, and this thing which we have used for various projects. And more than 1,000 people have contributed to more than 1 lakh handwritten word samples in Tamil and Kannada. My mother tongue is Tamil. I am in Karnataka, where Kannada feeds me. So whatever I have done for both Kannada and Tamil. And currently we are working on speech recognition. Again, we have collected more than 1,000 people, speech from Tamil, Kannada, and Hindi. So the mission we created in 2001 is that we will create Indian language reading machines for people with visual disability. And we call the project as Automatic Book Reader, where we said any printed material in Indian languages becomes accessible to blind people. So that took us to the field of document analysis and recognition. Very soon we found that if you just bring braille books, it's not enough. People want to listen to it directly as audiobooks. So we moved from there to text to speech conversion also. And then we realized that originally I said I will not work on English because everybody in India and elsewhere in the world are working in English, so I will work on Indian language. But later I realized that whatever books I scan, along with Tamil, there is also English. Along with Kannada, there is also English, sometimes Hindi also. So we had to deal with bilingual or trilingual text. This took us to the new research problem of script recognition at the word level. And then mobiles came and people started capturing text images from the mobiles also. So that took us to reading text from posters, road signs, menu cards, etc. And that took us to camera captured document analysis and recognition. And also recognition of text written on tablets, mobiles, etc. So that's a brief introduction to our lab, what we did. So let's come back to the topic of today. I told you, I call it hard-coded features in the sense that, you know, if you have a Fourier transform as an input to, let us say, a speech recognition unit, so that's a hard-coded feature. It will always do the Fourier transform. It's not programmable. It doesn't learn from the data. It doesn't do anything. So whenever you give data, it computes Fourier transform. But usually the deep neural network layers, as you know, it has got so many weights, and depending upon how it is connected and the learning algorithm is there, the weights keep learning. So I'm not talking about that learning mechanism here. That is very well there and it is useful. Apart from that, I'm talking about whether hard-coded, you know, permanently working feature extraction stages are useful in that and how they are present in the brain. And since this program is about machine learning, I saw all the topics, most of them are application oriented, I saw, and there are also good hands-on experiences sessions are there, which is very nice. But many a times, you know, students come to me and they say, I know machine learning. They just go to, you know, some Andrew Ng's program and they think they know machine learning. But machine learning, before you come to that, if you want to really contribute as a research, if you are in industry, without knowing anything, you download a package and put an input and take the output. That also, you know, people call machine learning. For that, you don't need any of this. But if it doesn't work, you don't know why it doesn't work. But if you are doing research, we need a lot of background before we come to proper machine learning or deep learning. And that background is linear algebra. You need to know complete matrix algebra. And then if you have a matrix vector expression, how to differentiate that, and probability and random process, the probability density functions and joint density functions of you know, multiple random variables, and then linear and nonlinear optimization. When you have a machine learning system or deep learning system, the learning takes place using an optimization algorithm where you are optimizing or minimizing or maximizing a objective function, and by changing that you can even change the behavior of the neural network. So optimization is an important thing, and these are all basic machine learning. But once you start applying to a particular thing, it may be digital signal processing, image processing, computer vision, speech processing, text to speech, or automatic speech recognition, or NLP, and there are other uses. You should also know what is already known in that. You can't simply jump into this thing and expect great results. Of course, sometimes you do get good results, but to really get the best performance, you should know what is already known, what is working in these fields like image processing or computer vision, and combine that with the best features of the neural network architectures. So now I will show you a few examples to you to convince you that the human vision system and the auditory system are actually extracting meaningful features which are hard-coded in the body itself. So visual system, first thing is believes in rich input. In other words, rich input means in a deep neural network, you can improve the performance in 3 different ways. By giving a rich input, you have an image, just instead of feeding just the image, you can extract some features, you can modify the image and do many things and then feed it. So that I call it a rich input. That also might improve if you know what you're doing. You can improve the network in terms of what types of layers are there, what types of transfer functions are there, linear, non-linear, and so on. And you can also increase the width and the depth of the network, the number of layers. So that is, you're modifying the network itself. Or at the output section, like I already told you, you can modify the objective function or the loss function or the cost function. So there are 3 distinct things that you can do. Now we are looking at the input part. So I told you that in today's researchers, majority of them, they expect the network to perform feature extraction also from learning the data. Convolutional neural networks are one of the major things that are used here. But you know that deep neural networks are basically supposed to be designed to simulate the biological neural network. But the biological neural network has feature extractors not only in the human brain, but even in the animal sensory systems. For example, those of you who know image processing, you know that if I give you a color image, RGB image, just by averaging the RGB values, R plus G plus B by 3, and putting that as one value, you can convert that color image to a black and white image to a reasonably good accuracy. So it's possible to extract gray image from the color image obtained by the cones in the retina. In the brain also it can do. It can just get only the color image, and gray image it need not get, so it can just generate that. But nature did not do that. If you know what is there inside your retina, the nature chose to have many more, in fact 20 times more rods. The rods are the sensors that sense black and white image. So the night time when you see, if you get up and if all the lights are off, and after some time you will still see things in a wake session, and but you cannot see the colors. You will see that only black and white. That time the rods are active, only active. In daytime, both rods and cones are active. So if you believe in God or nature, it has provided 120 million roughly rods in the retina compared to only 6 million cones, which are the RGB sensors. So in other words, the retina not only extracts color information, it also extracts black and white information, and at 20 times the resolution. So the in the nature, or if you believe in God, I believe in God, it doesn't matter anyway. So it is not foolish, it has evolved. Even if you believe in evolution, it has evolved in a way that optimizes our performance. So the nature has decided that this kind of rich inputs is going to improve our vision. So I will show an example where such a rich input, when given to a deep neural network, gives much better super resolved images from intrinsically low resolution binary document images. So you can see here. So most of the cases, there are some cases where we have designed our own deep neural network, but in many cases what we have also done is we took what is the best available the configuration of the architecture in the literature, that is in the published papers, and then using our ideas of the nature of the problem and the nature of the image processing or a signal processing or a speech processing problem, we have modified, like I told you, the few other things and improve the performance of the existing network. So here the problem is given by one of my friends. So what they had is they digited around 50 years of newspapers in Tamil. They scanned the newspapers and disposed of the newspapers. And now they want to recognize all the text, and they wanted to create a digital library out of it for a particular organization. And when they started using my OCR, the accuracy was very poor, around 35-40%. He called me from Chennai and said, your OCR is useless. I know that my OCR is good because, like I was introduced, more than 600 books have been digitized and converted into blind, the braille books used by blind students. We have got international awards. So I told him, there is something missing here. You send me the images. When they sent the images, I found that they have not carefully taken the images. If you take flatbed scanners, they have, if you just don't set anything, it will just put a black and white paper like a newspaper. It will just scan it as the binary image. That is, there'll be either white or black, and they have scanned it at low resolution and also binary. So most of the information is lost. I will show you some example later. So I told him the way it is scanned is very bad. Please rescan it. I want gray level image. That means it should be like the, you know what is gray level image. So I want at least 256 level gray level, and 300 dots per inch the resolution. They had scanned it at 100 dpi and binary. He said, no, AGR, it's not possible. I have disposed of the original newspapers. Then I said, forget it, nothing can be done. This cannot be done, forget it. Then he said, no, please do something. So that is how this project started. And so this is one of the initial experiments, but there are other experiments we have done. So here, I want to compare this with the idea that we got from the retina. So the input, normally in a neural network, if you want to do, this is called a super resolution problem. What I want, I didn't want to change the OCR, but the input image is bad. So I want to use a neural network to improve the resolution or enhance the image so that the same OCR now gives you much better output. So basically from 100 dots per inch, I want to get it at 200 dots per inch or 400 dots per inch, like that. So one of the simpler way in which we can do that is nothing but interpolation. And those of you who have studied image processing, you know that there are simple interpolation like bilinear interpolations, nearest neighbor interpolation, where you are just replicating the pixels, bicubic interpolation, and so on. And so these are the standard techniques. But what we did is that when I increase the resolution from 100 dots per inch to 400 dots per inch using any of these interpolations, the OCR, you can see how bad it is. This particular page, there was only 4% accuracy in the recognition, but that increases to 7% or 15% or 16% just by interpolation to 4 times. And now what I did, so you can see that the nearest neighbor surprisingly is doing better than the others, but other things are also giving something. So we wanted to see what if I combine all of this with a neural network. So that is what is happening here. You can see there is bicubic interpolation here, nearest neighbor interpolation here, bilinear interpolation. All the outputs are coming and they are combined using a deep neural network. It's not very deep actually. They had only 3 layers, so I cannot even call it a deep. It's a neural network, you can say. And there is an output. Of course, you can't train such things with a very big image because a newspaper has, something like 4,000 by 4,000 pixel, and it's huge, this thing. So we divide into small patches and train it. So that is how we have done this. And you can see that after we train this, we call it as a nonlinear fusion of multiple interpolation. Multiple interpolation is these 3 interpolations you said. We can even use more than other interpolations also. And then we fuse them because we are combining all of them. And because of the nature of the functions here, it is a nonlinear combination. And we get around, from 16.48, we get to almost 22%. That is an increase of around 5.5%. Of course, the input itself is very bad, as you know, 100 dpi. In our OCR, we tell people that minimum scanning resolution is 300. So this is where we could get at that level. So we refined it quite a bit, and the current one which is working is called the document image super resolution using convolution, deconvolution, subpixel convolution architecture. So this we have filed it as a patent in 2018, and we claim that it improves not only the OCR performance, but suppose you have a digital library and you have a low resolution image, people who access this over the network, they can also read it much better. So the same idea is also extended to natural images, and this is also there. We have submitted it as journal papers now. So the basic ideas of this have been published in 2 international conference papers, and also Sadhana, which is a local journal. So here I give you some examples of how things are there. So let me see. Yeah, okay. So you can see this is the original image that I got. You can see that even if one of you, if anyone knows Tamil, you can try to read it. It's so difficult for even a native person who knows Tamil to read it. Some of them is possible because so much is lost in the scanning. So this is what I call a very bad scanning in the binary image which is scanned. And when we pass this through the Tesseract OCR, we have our own OCR, but for publishing and for patenting, we have to show some standard things. So this is Google's Tesseract OCR. We ran it, and you can see the quality of the image is so bad, but for 2 lines, it almost gives everything as English, and somewhere we can even some Chinese characters have come. So from our network, when we process this, you can see that this image has now become this image. Now you can see that this is what we call as improved readability. So anybody who is from a Tamil language, they can actually read it, even though it's not perfect, but because of your knowledge, and so you will be able to much better read this compared to this. And now when this image is sent to the same Google's Tesseract, yeah. So you can see that still there are errors. I won't say that is very good, but at least there are no Chinese and English characters, and majority is Tamil, and you will agree with me that the output of the OCR is much better than this. And this is independent of the font and everything else. We have tried it on different fonts, and we have tried the similar idea for Kannada also. It works. Okay. So now that was an example in the visual system at the input. There are other feature extractors I want to show you. So visual, I'm also going to look at the auditory processing, that is the ear, how it hears, and so on. So in the visual system, there are Nobel laureates Hubel and Wiesel. They showed the existence of orientation selective cells in the lateral geniculate nucleus. This is the first processing element after the signal leaves our retina and before it goes to the visual cortex. So they showed that orientation selective cells exist not only for this thing, but it's also for the kitten, for monkeys. Now all of that, it has been proved. So I will show you what I exactly mean by this in the next slide. And then also in the auditory pathway, different regions of the basilar membrane, this is in the inner ear. You would have seen the coil-like cochlea. The cochlea has this basilar membrane, and that responds to different frequencies both in man and animals. And the way it responds is similar to subband decomposition or a wavelet decomposition of the input audio. So this shows that in the case of vision, there is orientation selective cells. In the case of auditory, there are wavelet decomposition kind of feature extraction. So there is hard-coded feature extraction in the brain, and obviously it has to enhance the classification potential of the biological neural network. So this is the Hubel and Wiesel experiment. You can see that they held tightly the head of a cat, and they showed different stimuli. These are bars which will have different orientation. Sometimes it is vertical, sometimes it is horizontal, some 45 degrees, 30 degrees, and so on like this. You can see here. They showed it, and they put micro electrodes into the brain in the vision area. And V1 is one of the what they call the primary visual area. So these recordings are from the V1. Unfortunately, this, I don't know whether, is it possible to remove this whatever is appearing on the screen, so that
Sir, which one, sir?
I am seeing the pictures of myself and others on the screen. If I can somehow suppress that, then I can see the whole screen.
Yes, sir. Sir, 1 second, sir. Sir, right side top
Yeah,
most, there
I,
view
I,
is there, sir.
I think I have been able to remove that.
There side by side speaker view, please you select, sir. Option.
Side by side
Right, speaker view.
Okay. Record on this computer, enable annotation.
Not there, sir. See, right
Ah.
side topmost, sir. Right side top corner, sir. Right.
Show thumbnail video, show grid video. Not this. I don't see it, but anyway, it has become a smaller window, so that's okay. And this one, maybe this one.
You can drag, sir, here also.
Yeah, see, every time I'm trying to drag, it's okay. So,
sir, is it not coming, sir? Right side, like
no, the photographs have gone, but still I have a big this menu panel.
One option is here, sir. Side by side speaker option. Only
I don't get it actually. I tried all the
okay.
buttons here. I don't get it here.
Okay. Oh, yeah, but it's very clear, sir, for us.
Okay. But I should also be able to read what is there.
Yeah.
Okay. Now it is better. Don't worry. Yeah. So you can see that. Are you also able to see my cursor?
Yes, sir. Yes, sir.
Okay. Okay. So you can see that these are the different orientation in which the bars are shown here at different times. And every time this is shown, the recording is done from multiple neurons, hundreds of neurons in the V1 area. They found that some neurons respond only to the horizontal pattern. Some respond to this, let's say 30 degrees. Some respond to 45 degrees. Some respond to 60 degrees. Some respond to 90 degrees, like that. For a particular orientation, if you change the orientation of the bars and you record from the same neuron, for the optimal orientation, it gives the maximum output. And then if you change the orientation on either side, slowly it decays. So it means like the tuned circuit, it is tuned to a particular orientation. So when we give a visual input and when our eyes see that, and the information goes to the this thing, not only for us, even for cats and the other primates, it is able to extract the edges of different orientations. This is what they found out somewhere, I think in 60s or something, and they got a Nobel Prize for this. So this is created by one of my students. So this is the human brain, and from the retina, he has traced, various things. First, it goes to this, what I call the V1 region, then V1, V2, V4, IT, VS. There are so many such regions. So I also told you LGN is one of the intermediate junctions here. And each of them do different processing. We even extract some of these basic features, and then some of the patterns are extracted here, and motion estimation is here, and so on. And so similarly in a neural network, you can simulate this. He said, you can have some feature extractors here, and then things which combine that and produce better and better information. And finally, you can go for recognition. So how did we use this information of feature extraction adding to neural network in our work? So this is facial emotion recognition. The problem is you are given a face image, and the network has to say what is the emotion. Interestingly, in this particular database, it's called FER plus, facial emotion recognition plus dataset. Around 35,000 images are there, which contains both training and test images. They gave it to 10 different people to ask them to say what is the emotion. Surprisingly, some of them say this is surprise, some of them say it is happiness. Maybe, it could be both. So it's the human recognition is also not unique. So when we use our recognition, we took whichever was the greater of the 10. If 7 is one emotion and 3 is another emotion, we have taken 7 as a thing to as a ground truth to recognize. Anyway, that's a different point. But the point I want to make here is, see, suppose this image, and the people have said it is either anger or disgust, and this is surprise. If you see the difference between this and this, here the lips are made very small by the person, and here the lips are open and very broad. So obviously it looks like the shape of the lips, and whether it is wide or this thing, seems to have some information which can be useful to the finding out the emotion. The other thing like that is, here it doesn't show so many images, but if you have seen, you can see here, see the surprise or happiness, you can see this, the eyelids are curved to the top, whereas here it is more or less flat. Here also it is more or less flat. So the curving of the eyelids also can give you some information about the, there could be other things, but these are prominent features. And those of you who worked in image processing, you know that this kind of information can be easily obtained through edge detectors, and the shape of the edge and the orientation of the edge will tell you how big is the lips and when they are doing this, and what is the angle at which it is these eyelids are rotated and so on. So what we thought is, if we can get some information about the edges and feed that along with the images to the best neural network, which is already doing very good facial emotion recognition, we suspected that it might do better. So this database is from this particular paper, which is collected by Microsoft Research, and they also used one network called VGG13. I will talk about it later. So this is what I am telling you. So if you extract the edges, you can see that the edges clearly show you the shape of this thing, and the lips and the eyelids. And this is the second derivative. I don't know whether you are able to see it, but I can see one small vague line here. Of course, if we enhance it, we can see it, but we have shown in the original thing. So every time this thing, the average brightness becomes 0, so you will reduce the overall brightness. So just by adding there is a standard network called RTNN, real-time neural network, which was published by this Arriaga et al. And they got 83% accuracy on this database. This database is slightly different. So it's called KDEF dataset, not the other one which I told you earlier. We'll come to that. So this is the gradient image, and we used a very simple Sobel operator. This is the second derivative. We have used a Laplacian operator, which are very standard things. Even in MATLAB it is there. And so the results on 4,900 test images with 7 classes. The original, when we did this work 2 years back, this was the best accuracy in the literature for this database. 83.16% they got. And by changing few things, this is what they call the transformer network we added at the input, and that alone increased by 1%. Along with the transformer input, we added the Laplacian, which is the second derivative, that you can see that it increased by 0.3%. And along with the transform network and this thing, instead of Laplacian, when we add gradient, that is the first derivative, it gives much better result, 1% improvement. And here you can see that these two doesn't have this STL. Here STL plus this Laplacian gives you still better. But when we combine all of this, STL with original image also, gradient also, Laplacian image also, now we get 88.16%. And most of you are teachers, you know that when somebody in your class gets 83%, you say is a great student. But if he has to go from 83 to 88, the amount of work he has to put in is really, steeply increases as we go higher and higher. Somebody who gets 40, if he gets to get 45, it's not very difficult. But somebody who has got 85 has to go to 90. So this is at that level, So this is the other original database I told you, that FER plus database given by Microsoft, and this is the network they used. And here they got an average performance of 83.85% on this database. Here the training set is 28,000 images, and validation and test set, each of them is 3,500 images, which are distinct. And there are 8 number of classes. That means 8 different emotions. So here again, this was what they reported, but when we implemented freshly, it gave slightly less, maybe because our implementation was poor, whatever. So this is our starting point, because we couldn't get this. So when we added the Laplacian alone, we got, almost 1.5% improvement. When we added Sobel alone, we got 86.42. In this case, when we added both, like the other case, we didn't get better results. These were the better results. So we have not fully analyzed why slightly it is different, but you can see that once again, from 83.85%, we have gone to 86.42%, which means around 2.5 or 2.6% improvement just by changing or making the input rich. And this is making use of the information that there may be very useful information in the edges as seen by us when we look at different facial images with different expressions, and then deciding that the edge detectors can extract that information and feed it along with the images. So that is what I'm saying. If you judiciously combine your traditional knowledge of image processing, and you also know some domain knowledge, what to look for, and you use an optimal architecture, then you can further improve that this thing. So this part was published in IIAP 2019 in Italy. So what we showed is the performance of any facial emotion recognition. We tried 3 or 4 different architectures in the literature. In all of that, we tried this, and in every one, we showed that it is improving. And in addition, we had our own network, and our own network also. The base model gives some 81.95%, and when we add the base plus Laplacian or base plus Sobel, you get around 2.5% improvement. And this is on the FER plus database. So we have already seen that FER plus database, the original thing obtained by Microsoft is 83.15. With it's a very deep neural network with 8.75 million parameters in the network, and we have only 0.36 million. So it's a ratio something like 24 times reduction in the network size, and still we could get with Sobel operator 84.47, which is 0.6 or 0.7% improvement over this. So not only that you can get better performance, probably, if you judiciously combine, you will also be able to reduce the amount of computation and the network complexity. And those of you who have worked on it, you will know that if there are 0.36 million parameters in a network, then the data that you require to train that network properly is at least 10 times that. That means I need 3.6 million images to train it properly. So if you increase it tremendously, then you also proportionally require more data. So that becomes this thing. You go for higher, deeper networks, and you ask for more data, and then it goes on increasing. And finally, we give more business to the GPU guys. So this is another one which we presented in IEEE 10Con 2019 in Bangalore. So here we are not only doing this modification in the input feature space, which is whatever I told you, extract the first and second derivative and add it. In addition, I told you there are 3 ways of changing. One is changing the network, one is changing the input, and one is operating on the output in terms of the loss function. Here we change the loss function. I already told you that the information of importance in emotion, apart from other things, is also there in the edges, because without adding edges also you can see that already 83% was there. So it's not only the edge, but edge is adding. We saw that from 3 to 5% it improves. So we also wanted to use that. See, normally these things, what they do is the output, when you see it matches an expected output to the actual output, you find out the error, and the error is propagated to train the network. So here we not only took the error from the output to the input image, but we also computed the edge information in the input image and edge information in the output image and the difference, and that also was used to compute the loss function. So it all not only reduces the reconstructed image, it also reduces the edge information also, change in the edge information, and that gave us a small improvement. So what led to that is a general loss function. We can use it for any such deep neural network based this thing. Normally deep neural network, they use what is known as the mean square error loss. So if Hj is the expected output, in this case I use H because we have worked quite a bit on super resolution, so this higher resolution, so I use H, and input is a lower resolution image, and the output of the network is some function operating on that function is decided by your neural network. So this is the output image, this is the expected higher resolution image, the difference, and this is the Frobenius norm of that, and this is the loss function usually minimized, what they call the mean square error loss. Why it's called mean square? Because you are taking the square of this and then you sum it over all the training images and then the mean. So that is how it is, mean square error. We modified it using a convex combination. Convex combination is you multiply this by some fraction. This mu is a positive number from 0 to 1, and this is what, if suppose this is 0.4, this is 0.6, so this is 1 minus that. So that is a combination, and this error is nothing but the edge preserving loss. As I told you, we use the canny edge detector on the output of the network, and canny edge detector on the expected output, which is the high resolution image, and that also we find out the square and mean and all that. So together this is minimized, and that improves the output image quality. So this is a super resolution problem. So this is a very standard one of the state of the art network in the literature, which gives super resolution image. This is output of that, and when I added this MSE, it slightly improves. You can't see it here, but the numbers I will show you. Similarly, ESPCN is original and after our modification. So you can see the improvement here. The improvement is marginal. So this PSRCNN is nothing but the PSNR obtained using that technique for after super resolution. This is the SSIM, which is another index which says structural similarity index for images, which is also used in compression of images and all that. So this is the original thing what is already there in the literature. This is when the same network we are taking, we are just changing the loss function and retraining it. You can see that from 28.44 this dB of PSNR, it has slightly increased to 28.57. So for each of those techniques like that, you can see there are 4 techniques we have shown: SRCNN, ESPNN, and so on. 2 techniques, sorry. So this is the PSNR and SSIM. In all the cases, you can see that there is a marginal improvement in this thing. These are different standard image data sets in the literature. This has 5 images, 14 images. These two have 100 images. So this change in the loss function that we proposed, we also applied it in the previous case. We applied it on a super resolution problem. In this case, we applied it on a denoising problem. You know that there are a lot of tens of thousands of denoising algorithms in literature. BM3D is very famous and so on. So whatever, again, we took the best or already working best architecture in the literature, and we showed that just by changing this this thing, we can improve this. It's a conference paper only, that proposal of this mean square canny edge loss function. Now it's more than 1,500 downloads are there in Springer, and at the rate of $25 per paper into 1,500, Springer has really made a lot of money. Of course, we didn't make any money. So this is the network which is already there in the literature, and all we did is just change the loss function at the output before feeding back the error. So this we submitted again, presented in a paper conference in Italy. So this DNCNN architecture was the original one which was there in the literature. So this shows the comparison of the result. So this is one of the best they had. Again, PSNR increased from 31.604. You can see that the improvement is only some 0.023, but this technique, like I told you, this denoising is such a overworked problem. Getting even a very small improvement is a big thing. And in our case, we did not do anything on the architecture. We just changed the loss function. So this was appreciated, and you can see that here also there is a minor improvement, and in SSIM also. Many times, if in the literature, if you see, when they improve the PSNR, SSIM will go down, or when they improve the SSIM, PSNR will go down. In our case, we got the improvement in PSNR without any reduction in SSIM. In this case, it has remained constant. In this case, third digits had increased. I can say that, okay, this can be almost that you can negligible, but we have obtained the improvement in the PSNR without any degradation in the SSIM, which is really significant result. So far we have done work on we have looked at the image part. Now we will come to some speech part. I have time till 1 o'clock, right? 11:15 I started, 12:45. Okay, another 25 minutes. I will end it before that. We will have
no problem, sir. 5-10 minutes at your convenience, sir.
Okay, right. So let us look at again, the theme of this talk is that there are hardcode feature in our sensory processing system on the way to the brain or inside the brain also. So this is, now we looked at the visual system, now we are looking at the auditory system. You know that this is the outer ear or the pinna, this is the channel, and this is your membrane, and this is the inner ear, the middle ear with all these bones, and this is the inner ear, and in the inner ear there are fluid filled chamber, and this is the cochlea that you have, and this cochlea is a coil, and if you can pull out that coil, you get a long membrane, and that is what is called the basilar membrane. And now hopefully this will work. You can see, I hope you can also listen to the sound. Let me see. Is it running? Yeah, okay, good. So we are going into the inner ear. This is a simulation. They are uncoiling this thing, and this is the thing that is inside the membrane. Inside membrane, there are other things in the. Are you able to listen to the sound also?
Yes, sir. Yes, sir.
Oh, very good. So what it really shows is the membrane has different width at different points, and one end it is very small, and the other end it is very wide, and depending on that, different parts of the membrane respond to different frequencies. Like your Fourier transform resolves the input signal into different frequencies. It is very interesting that our basilar membrane is actually able to resolve the input signal into different frequencies, but it's not like one frequency, it's like a band. So that is why I said it's like more like a subband decomposition or a wavelet decomposition. Now it is combining many areas. if you have any questions, you can ask. What the point it makes is, see, the sound that you heard is not produced by this. The sound is impinged on this. So when initially you have only a one frequency, low frequency tone, or middle frequency tone, or high frequency tone, at that point only a small area of the membrane is moving. And finally, when you see a very complex sound like a philharmonic or whatever, then there are multiple frequencies there, and then most of the areas are this thing, and at each of these areas there are sensors which are called outer hair cells and inner hair cells, and they pick up this movement of this membrane, and that is converted into electrical signals, and that goes into your auditory nerve. So this idea, we have used it in our Tamil speech recognition system. Okay, I think we can show this later. Okay. So the basic idea here, what I told you, is that it is actually extracting features which are dependent on the frequency of the input signal, or if there are multiple frequencies, there are multiple areas of the membrane are vibrating, and they are picked up by different sensors. So you are basically resolving the input into the different areas, different frequencies. So this is a speech recognition system that my student has built for Tamil, which we presented in 10Con 2019. So usually speech recognition systems are described in its performance is described in terms of word error rate. That is, if you give 1,000 sentences which have around 1,000 words, how many of them are correctly recognized, how many of them are wrongly recognized. So if 100 of them are wrongly recognized, instead of saying that the accuracy is 90%, we say word error rate is 10%. So the lesser the word error rate, better is the system. So this has a vocabulary of 1,75,000 words now. And the baseline model, which is a comparison model, is trained on this is some kind of subband features, and this is MFCC, which is a very standard thing which is used in speech, Mel frequency Kapstel coefficient. And what we added is a scattering transform, which is more like a wavelet transform decomposition. And you can see that there are multiple models here. This is the DNN model. These are HMM based models. So the LFB features give around 13.48% word error rate, and the MFCC gives slightly more here. When we use scattering transform of order 1, this reduces by 0.4% compared to this, and 0.3% compared to this. And when we use scattering transform of order 1 and 2, then you get a further reduction of 0.8% compared to here. But if you go back to this, so it's a reduction of around 1.12%. And if you're working on speech recognition, 1.12% is like, it's really a PhD work, because people publish papers for 0.01% improvement also. That is where the stages is there. So this reduction is highly significant for the automatic speech recognition, especially for Tamil language. You know that there are not many systems worked by at least academicians for Indian languages which have vocabularies comparable to this. Some industries say that they have, but none of them have published, so we don't know what exactly the performance and so on. So now the next thing I want to say, in the biological neural network, that is what is happening inside our sensory processing, is that there is a very rich feedback. And even in neural network, you normally think that there is a feedback, but that feedback works only during training. You give a set of training images or training signals, whatever, and you are getting the output. You know what output to expect. Initially, the network will not get the right output. So you find out the error between the expected output and the actual output, and the error is fed back using back propagation or some other algorithms, and the weights are changed till the error is minimized. So this is called actually definitely feedback. But once you say the network is trained, then there is no more feedback. Now you say that the network is trained, all the weights are learned, and you just store the weights. And now you just give, when you are testing time, you just feed the input and you take the output and you say, okay, I got 98% or 95%. Whatever you get. And there is no way of saying why it did not perform better or why it performed better. And but there is no, what I want to say is there is no feedback when the actual test data is given, test recognition time. But in the case of human brain, maybe in animal brain also, there is feedback going on all the time. Even when you are doing testing, when you're actually recognizing something, there is feedback going on. And in 2010, I proposed this as, I gave the name attention feedback. And we published, we submitted as a patent. Unfortunately, the Indian patent things are so slow that we got it only very recently. But in the meanwhile, you know, the word attention has become a big thing in deep neural network. So there are two sets of things here. You can see that these are the inner hair cells, these are the outer hair cells. They are on a layer on top of the basilar membrane. You can see the basilar membrane, what we saw is just this one. On top of there are multiple structures, and where these outer hair cells and inner hair cells are there, they are the sensors. When the basilar membrane vibrates, these things also move like this. You can see that they are moving to the left and right. And because of the way they are designed, some ions move in and out of the cells, and electrical signal is produced, and that goes to the auditory nerves. That is how the transduction of the speech signal or the audio signal happens into electrical signals in the inner ear. So you can see how when those things are moving, you can see that potassium and sodium ions are moving in and out. And those of you who studied about excitable cells in biomedical signal processing and all, you know that, you know, whenever a cell is excited, the the voltage becomes from minus, it becomes to plus with respect to the outside. So that's called a excited cell. So similar process is there in both inner hair cells and outer hair cells. The point here is, I need to give you a little background of how it works, but the actual point I told you is about the feedback. And I told you this feedback is going on when during the recognition and how it is there. Again, you have an expanded view of this. So basal membrane is at the bottom. So these are the outer hair cells you can see, and these are the inner hair cells, and there are other things. Let's not bother about it. So you can see that there are two different shades of colors here. So there is one orange. This orange, they call it afferent fibers. Okay, afferent fibers, and the maybe brown, which is called the efferent fibers. So efferent fibers is the signal is coming from the brain to the periphery. Afferent fibers, the signal is going from here to the brain. So basically, these inner hair cells are the majority sensors which sense this signal and take it to the brain. But the feedback, while this is working constantly, feedback is coming from the brain, and it is operating on the outer hair cells, and there are connections between outer hair cells and inner hair cells. And so when you are listening, some initial recognition can modify this, and the outer hair cell can change the gain and the processing transfer function, if you may call it, of the inner hair cells. So actively there is feedback from the auditory cortex into the inner ear, and through the outer hair cells, the response of the inner hair cells itself is being modified in real time, which is not there in any deep neural network today. And we captured this at that time. To 2010, I attended a course in neural network, biological neural processing, when the Center for Neuroscience started in IIIT. So based on that, we proposed this. So at that time, we were not working deep neural network. So without deep neural network, conventional the machine learning technique in SVM based technique, we applied this idea of active feedback, and that is what I call attention feedback segmentation. So that was in the auditory system. Now we can see that similar thing is there in the visual system. This is called a, I tell you, rich feedback in the ascending visual pathway. Feedback, I already told you. Why is it rich? We'll tell you in a minute. So this is the X cells and Y cells are there in our retina. So from there, the signals are coming. These are all processing elements or junctions, you can call it, or neurons. The signals are coming from the retina into, already I told you, the first processing element in our visual processing thing is called the lateral geliculate nucleus, the same thing LGN here. Then you have PGN, and then it goes into the cortex. In cortex, you have different layers, 1, 2, 3, etc. We saw that, and there are other names. Let's not bother about it. But here you can see in the LGN, there are different colors. The green color is actually, it says cortex. That means from the cortical neurons, the signal is actually coming as a feedback all the way up to LGN. And you can see there are many of these. And this afferent, that is what is going from the retina into the cortex, is that yellow color, and the yellow color neurons are only 7%. So if there are 100, the synapses is one neuron talking to another neuron, which is how we are learning, which is how the memory takes place, and so on in our human brain. So that is happening here in LGN itself. And out of the 100 neuron connections, junctions, which are called the synapses, 7% are only due to the afferent or the connections coming from retina. 31% is due to feedback connections from the cortex, and another 31% is local connections within the layer. So that, let's forget that within the layer. So if you look at 7% and 31%, this is more than 4 times, around 450 percentage amount of feedback is there compared to feed forward. So all our pattern recognition systems are feed forward networks. You learn something, and then you get some features, and then have some classifier, and then some output, maybe some post processing, and that's it. So there is no feedback. Here, as you are recognizing, there is a feedback, and that can change even your feature extraction. That is what we exactly did. We did some recognition using SVM. We found out some errors, and using the errors, we fed back that signal, and we modified the way the image is processed so that we get better accuracy in our OCR, also in handwriting recognition. And we have applied patents for both OCR and handwriting recognition. So these are our OCRs, Mori Ballan in Tamil and Lipignani in Kannada. So I told you we are using this information of feedback from the cortex to the visual or the auditory system, and using that, of course, doing other things. Also, we have now beaten Google's Tesseract OCR. So it's not easy to beat something that Google does. Google has OCRs in all Indian languages. And this paper we submitted 1.5 years back. And then since we said we are doing better than Google, it went through real tough testing. And finally, we managed to publish it in ACM Transactions on Asian Language Processing in this May. And we published the test data of around 400 images on GitHub. So everything is done. So without, nobody can question that we established that. So there's saying a few things about our OCR. You know, some of our images are obtained from books which are published in 1950, because OCRs are basically useful for old this thing, and there are Kannada numbers which are similar to Telugu numbers, and then the poetry is there, the bold text is there, italic text is there, and the Indo-Arabic numerals are also there. Tables with numbers are there, you know, English words are there here. All of this our OCR handles. That's why we could beat Google. So the main challenge in OCRs is not recognition. Everybody thinks that, you know, recognition is the thing. Thousands of papers are published with some standard you know, character database from US, and they think they have done great stuff, but those things will not do, then it will not work at all in practice, because recognition is not the challenge in whether it is speech recognition or character recognition or handwriting recognition. The real problem is segmentation. So what do you mean by segmentation? In the old books, what happens is two characters, they merge. In Telugu also, many of you may know Telugu, I suppose. Some of you may know Kannada. You know what is known as the othus. The half consonants, unlike in Hindi where they occur at the left, the half consonants occur at the bottom. And sometimes in the older books, they are printed in an odd manner, not in a continuous line. And they are so low that they go and touch the next line, or they are very up, they touch the same line, or due to the ink flow in the old, this thing, the way it was printed, the characters may merge. So there are merges, there are broken characters, and all of this is a problem. And this is a very simple overview of this.
Sir, good afternoon, sir. It is in mute, sir. Sir, voice is not audible, sir. Sir, it is in mute, sir. Hello, sir. Ramakrishnan, sir. Sir, your voice is in is not coming, sir. Which is in mute, sir. Sir, now voice is
Are you able to hear now?
Yes, sir. Yes, sir. Yes, sir. Yes.
So
please.
when did you lose it? Should I go back or continue?
No problem, sir. You can continue, sir.
Okay, okay.
More 5-10 minutes, no problem. Up to 1 o'clock.
Right. So you can see that this image of one word, you can lose. Many of the things are lost here. The dot in the saw is almost there, and when I binarize, it is still worse. And after I binarize, I segment this. This becomes 2 pieces, and this is the recognition. So,
sir, PPT is not shared, sir.
Oh, I see. Okay.
Yes, sir. Yes, sir.
My God. Where is this?
Sir, downside share screen is there, sir. Green icon.
No, I'm not able to go to the Zoom window at all.
Sir, there might be Zoom symbol would be there. So just you click on one, sir. The bottom line. Bottom in icon, sir.
Yeah, I'm clicking, but somehow I can see your photograph, but when I click, it doesn't go there. What is that thing? Okay, here it may be there. Let me see. Recording.
Yes, sir. Just
right,
beside
yeah.
recording, sir. Beside
Right.
Yeah. Yes, sir. It started coming, sir.
I don't know how to remove this fellow.
Just you close it, sir.
Okay.
Yes, sir. Yes, sir. Now it's clear, sir.
Right. Is it fine now?
Yes, sir. Yes,
yeah.
fine,
So
sir.
basically, this word after binarization, because it is badly segmented, this becomes 1 and 1. So if you use just some standard database of even 10,000 characters, handwritten, whatever, and then you say that my recognition is 99.99%, and you use that on this kind of images, what we have, I am sure the OCR or handwriting recognition, whatever system will not work. So that is where I'm saying the problem is not in recognition. The problem is in segmentation, because when the segmentation is wrong, I get patterns which are not known to the recognition system. The pattern recognition system, the classifier has not seen this pattern, and that is the problem. If you solve that, then your thing will improve. So we have some method of once I detect that something is wrong here, the one of the simple way of detecting is that, see, I'm expecting a word, unless it is your the registration number of your car or a bike, you won't have both numbers and characters in the same thing. So you can suspect that there is some error. So you can go back, either it should be all number string or it should be all character string. So that's like that. There are many checks we have. It's one of the checks. So we know that segmentation is a problem. So we go all the way back to the gray level image and we do some processing on the gray image, which called as a gamma correction. So after that, when I binaries, you can see that it is much better now. So this is the very first pre-processing itself. Like I told you that how you get feedback to the inner hair cells from the cortex. This is the feedback from all the way from a recognition engine to the basic first block, which is the binarization block or pre-processing block. After that, segmentation, recognition, everything is great. Of course, it doesn't mean that all 100% I'll get it, but many things are improving. And similarly, this is for characters where it gets broken. In some other cases, it is very thick, and all of this can become merged into one word. Then also there are problems. So we have addressed both of this, broken characters as well as merged characters. And with all that, finally, if you see in our 250 images, standard images, which I told you, with the ground truth, it is there on GitHub. The Lipignani, which is our OCR, is giving 96.25% accuracy at the Unicode level, whereas Google's Tesseract 4.0.04 or something, the current version, is giving 95.41%, around 0.8% less. And these are all various statistics related to how many words, etc. And this Unicode accuracy works out to word accuracy. So our thing gives 81.5% word accuracy, whereas Google's Tesseract gives only 76 points. So we are better off by more than 5% in terms of word accuracy. So like once again, like I said, as we go to the higher levels, the small difference makes a huge difference here. So these were the basic information on this, how we can use, information like this, feedback like this, and improve the binarization and the segmentation was published in NCC 2019. So with all that, there was a NGO, kannadapustaka.org, who used our Kannada OCR and text-to-speech also, converted all the school books from 8th standard to PUC into both braille books and audio books. And Tamil also, I told you, around 600 books. This is my student and also my partner in my current startup. So we got this Manthan Award for this OCR work, and he got this Gandhian Young Technological Innovation Award. This was in Rashtrapati Bhavan. And then our text-to-speech, which is in Kannada, which is called Madhura Vachaka. Madhura means sweet, and Vachaka, we gave a nice name for it. So for that work, we again got the Manthan Award in the next year. So that comes to the end of my talk, and I think I almost finished at the right time. Yes, only 2 minutes late. So I want to acknowledge all the people who have contributed to my life, and finally to all of you in the audience, and Professor Janardhan, who arranged this talk for me. And any questions you can ask me. If you have time, please, I am available.
Thank you very much, sir. My dear participants, please, you can interact yourself with the resource person. You can unmute yourself and you can interact. Participants, you can even post in the chat box also.
Sir, good afternoon, sir.
Good afternoon.
Sir, one small query from my side, sir.
Okay.
Why we need to give only a gray color image for converting it into binarization?
See, the word binarization.
Yes, sir. Only black and white. 0
Yeah.
or 1.
Correct. So 0 and 1
Yes, sir.
is a nature of an image after you do binarization. Binary means what? 0 and 1, right?
Yes, sir.
Binary coding we say, na?
Yes, sir.
So if you want to convert something to binary, obviously you have to use binarization, and there is no point in giving a black and white image and binarize it, because it's already binarized. Only if you have gray level image, it will binarize. So I don't understand what is your question.
The thing
Only
is,
if I have a gray level image, then you need binarization. If it is already binarized, I don't need binarization. So the input to binarization can always be only gray level image, or it could be color image, of course.
oh, okay, sir. That is. Thank you, sir.
Yeah, in the case of camera captured images, there also we use binarization, but our input is color image.
Yes, sir. Thank you, sir.
Yeah, participants, any other questions from your side, my dear participants? It seems no questions, sir. In fact, it's a very true practical aspects of fundamental research. As you said right at the beginning, that with this session, immediately participants will not be in a position to gain to the possible extent. Definitely, participants will get motivation in this direction. I personally even feel that it's a very fundamental research. The people, whoever are participants, whoever are working in this direction, surely might have got very good concepts. Even other all participants could have got complete motivation with this. It's a very, very practical researcher. From my personal behalf, on my on behalf of my institutions, I really thank you, sir, for your kind consent and sparing your valuable time with us in spite of your busy schedule. It's really very happy, sir. You have enlightened the complete concepts on hard-coded features in the brain, deep learning in the brain using deep neural networks, and the foundations for machine learning. Then current emphasis on DNN, super resolution of binary document images, improve readability on the different images, visual or auditory processing, extract fundamental features, feature detection, hard-coded features, argument, derivative features, then edge processing loss function to improve super resolution, then DN-CNN architecture, denizing results on BSD68 dataset. At the same time, we have given complete insights of basilar membranes. Here performs sub-band decomposition, hair cells, true practical aspects of research hair cells, and rich feedback in the ascending visual pathway, and OCRs for Tamil and Kannada, non-linear enhancement, performance of Lipi Gnani versus Google's as if is Tessar SAC OCR. Really, it's a very great lecture, sir. To all of us, it's a very once again great opportunity to have your session with us. Once again, I thank from my side and on behalf of my institution, sir, for your gracious presence with us today, sir.
Yeah, thanks, Professor
Thank you
Raju.
very much, sir.
So, like I already said, I didn't teach anything in machine learning, but
Yes,
I wanted to emphasize that the convention knowledge is also important, and you need a holistic this thing. And from your summary,
sir.
I was very happy that you have listened so carefully, because all of us as teachers are first students.
Yes,
A good teacher is a lifelong student.
yes, sir.
So I'm happy that you so intently listened and summarized very well. So I thank all the participants. Thanks for the opportunity, and wish you all great career and knowledge. Thank you.
Thank you, sir. Thank you very much. Once again, thanks to you for your gracious presence with us. Definitely, our program has a different value with your gracious presence, sir. Thank you, sir.
Thank you.
Thank you, sir. My dear participants, the next session will be sharp by 1:30. The session will be by Professor P. Krishna Reddy Garu, who is from IIIT Hyderabad. The session is on experiences of building IT-based systems to deliver actionable agricultural information to Indian farmers. Okay, be back to the right time by 1:30 sharp. In fact, sir will be available by 1:15 onwards. Okay, thank you very much, my dear participants, for your right patience. Hope every one of you are very active and utilizing the sessions very carefully for your future research and in the right direction. Thank you very much.
So I think okay. So somebody is okay. Okay. Hello, everybody. So I hope you can listen to me.
So maybe after your introduction, we'll take, sir. Thank you.
Okay.
Respected, today's resource person of our 6 days program, which is an ISTE-STTP on machine learning applications research challenges. Professor P. Krishna garu, who is from IIIT Hyderabad. Dr. C. V. Krishna garu, he is our director of our institutions. Our coordinator, Dr. K. Rameshwari garu, deans of our institutions, School of Pharmacy and School of Management Sciences, respective heads of various departments and other faculty members. Very importantly, participants for this program. Very good afternoon to all of you. Warm welcome to our present session. It's really my privilege to introduce about today's resource person, Professor P. Krishna garu. Professor P. Krishna Reddy is a faculty member at IIIT Hyderabad. He is the head of the Agriculture Research Center and the member of Data Sciences and Analytics Center research team at IIIT Hyderabad, India. During 2013 to 2015, he has served as a program director, ITRA, Agriculture and Food Information Technology Research Academy, ITRA, Government of India. From 1997 to 2002, he was a research associate at the Center for Conceptual Information Processing Research, Institute of Industrial Science, University of Tokyo. From 1994 to 1996, he was a faculty member at the Division of Computer Engineering, Netaji Subhash Institute of Technology, Delhi. During the summer of 2003, he was a visiting researcher at Institute for Software Research, International School of Computer Science, Carnegie Mellon University, Pittsburgh, USA. He has received both MTech and PhD degrees in computer science from Jawaharlal Nehru University, New Delhi in 1991 and 1994, respectively. His research areas include data mining, database systems, and IT for agriculture. He has published about 160 referred research papers, which include 22 journal papers, 3 book chapters, and 6 edited books. He is a steering committee member of the Pacific Asia Knowledge Discovery and Data Mining, which is PAKDD, Conference Series, and Database Systems for Advanced Applications, DASFA, DASFA, Conference Series. He is a steering committee chair of Big Data Analytics Conference Series since 2017. He was the proceedings chair of COMAD 2008, a workshop chair of KDRS in 2010, media and publicity chair of KDD 2015, and general chair of BDA 2017. he has organized the 14th Pacific Asia Conference on Knowledge Discovery and Data Mining, the 3rd National Conference on Agroinformatics and Precision Agriculture in 2012, and the 5th International Conference on Data and Big Data Analytics in 2017. He has delivered several invited or panel talks at the reputed conferences and workshops in India and abroad. He has got several awards and recognitions. He has executed research projects by raising the research funding of about 80 million Indian rupees. Since 2004, he has been investigating the building efficient knowledge agriculture, knowledge transfer systems by extending developments in IT. He has developed eSago system, which is an IT-based farm-specific agro-advisory system, which has been field tested in hundreds of villages on about 50 field and horticulture crops. He has also built e-agromet system, which is an IT-based agro-meteorological advisory system to provide risk mitigation information to farmers. He has conceptualized the notion of virtual crop labs to improve applied skills for extension professionals. Currently, he is investigating the building of crop darpan system, which is a crop diagnostic tool for farmers with the funding support from Indian-Japan Joint Research Laboratory Program. He has received 2 Best Paper Awards. The eSago system, which is an IT-based farm-specific agro-advisory system, has got several recognitions, including CSI, Nihalant E-Governance Project Award in 2006, Manthan Award in 2008, and finalist in the Stockholm Challenge Award 2008. My dear participants, as all we know, the entire India is due to agriculture-based country. We are really very happy such a great personality with us whose complete research is on agriculture. I really thank you, sir, on my personal behalf and on behalf of our institution for your kind acceptance and sparing your valuable time with us. Thank you, sir. Thank you very much. Over to you, sir.
Okay. Okay, am I audible now? Okay.
Yes, sir.
Okay. So I'm going to share my screen.
Yes, sir.
Yeah. So my screen is appearing, isn't it?
Yes, sir.
Okay. Okay, good. So, yeah, so already Dr. Janardhan Raju Garu has already had a long introduction about me. So quickly, I want to know about your background. Can somebody, just one by one, say their names and where are they from, so that I can have some perception regarding participants. Just a minute.
Sir, good afternoon, sir.
Yeah.
Myself, Dr. Rameshwaraya, HOD CSC in Nal Reddy Education Society Group of Institutions, sir. I'm also a coordinator for this program, along with my Dean School of Engineering.
Can you just actually, so let us see. So can you give me some picture of who are the participants actually? Because
almost more than 80% of the faculty members only, sir. They belong to computer science and engineering. 80%, more than 80% of the members.
Then we can skip the introduction. Let us start the talk.
Okay, sir. Okay, sir. Thank you.
So now I'll move this one here somewhere. Okay. So the title of my talk is Experiences of Building IT-Based System to Deliver Actionable Agriculture Information to Indian Farmers. So normally the word information technology is very popular for last 20 years. So I started this research about 20 years back. So I started with information technology. Now the new kind of terms are appearing like data science, machine learning. Actually, it doesn't mean that I'm not applying all those things. So I kept this as IT only, but we can also change it to data science-based systems, machine learning systems, rule-based systems. So I'm exploiting all kinds of ideas to help the farmers. So somebody is waiting actually. So okay. So before that, anyway, you are all computer science students, the faculty. This year and next year, because I'm organizing 2 conferences. One is 8th International Conference on Big Data Analytics, BDA 2020 at Ashoka University. This is BDA 2020. I think, let me see whether I can get it. Yeah. So this is a BDA 2020 website. So actually, this is the 8th in the series. I'm the steering committee chair. So this conference is from December 15 to 18. It is online. The registration fees might not be much actually. So you just, if you want to know, so you see who are the keynote speakers. We have wonderful keynote speakers, Professor Masar Kistriga, Professor Divyakant Agarwal, Professor Uri Ulsan, Professor H.V. Jagadish, Professor Amit Sayed. We got invited speakers and Carloj, Professor Carloj, Professor Marcin, and Professor Praveen Rao, and Professor Raju Gupta, Dr. Raju Gupta. So this conference will give you all kinds of latest advances. So the topics of the conference is all analytics as service, architectural design, and the proceedings are being published already.
Sir, your PPT is visible, sir. That website seems you have opened one website now, sir. That is not visible, so I think you have to go once again new share, sir. You have to select that window, sir, for slide sharing.
Oh,
every time whenever we change the slide, we have to.
Yeah. Okay. So
new share. Yeah.
Yeah. Okay.
No, that is okay, sir. Now you have, it seems you have opened one. You have clicked, it seems, and some website is opened, sir. That website information is not visible to all of us.
So what should I do now?
No, please, sir. Once you open that website, sir. Now you come to bottom line, sir. Share screen or new shares. Some green icon is there, sir. Bottom. Yeah, you select that one, sir, and now you select the window to be open up, sir. That is website window. Now multiple number of windows already opened.
Okay.
Now that respective.
New share is there.
Yes, sir. Please select new share, sir.
No, okay.
And now you select that website window. You select now.
Now it is okay now.
Yes, sir. Yes, it's true.
So this is the 8th International Conference on Big Data Analytics, and we are holding this conference in different cities. I organized this conference in Hyderabad. Then before it was held in Delhi, Bangalore, now Ahmedabad, now in Delhi. So all of you are requested to register for this conference. And these are the accepted papers. Already deadline is over. Next year you can try to submit a paper. There is no problem. Every December this will be held. If someone is doing PhD, you can plan a paper next year. And there are keynote speakers, and here, so Professor Masar Kistrigawa, Divyakant Agarwal, then invited speakers, and it will be excellent. There are tutorials also, and there are tutorial speakers and everybody. So this is one thing. The another one is PAKDD. So the other conference I am organizing is in next May 11 to 14. Okay. So the paper deadline is already, so it is November 23rd. Paper submission November 30. This is international conference we are organizing in Delhi. So I am the general chair of this conference. So please. Participate in this conference, submit a paper in this conference, there will be a lot of workshops. Actually, recently we had a wonderful workshops. Several workshops are being selected, and now paper session is going on. So there's a paper deadline. If you want to submit the paper, you can submit, no problem. The paper deadline is here after submission, November 30 and everything. So you one thing is that you try to submit a paper to workshop. There will be excellent keynote and tutorial. This is a world-class conference. PKD is one of the top conference. This is the 25th conference. So you don't know, we are going to receive about 500 research papers, and we are going to select about 100 or 120 kind of thing. So this is very difficult to enter, but the program will be very interesting. So all of you, I will declare the registration, everything in January. I will again come back to you. I will take contact from Raju Garu and I will send a mail to you. So one thing is that I request you to participate in this conference. So mostly it will be offline and online. It will be held in Jawaharlal Nehru University, Delhi, and that is what we are both are organizing. But online, we are going to have a hybrid conference. So with this, I will move forward. Now there's a new share now. Pause share your screen.
Yeah, your PPT can, your presentation can select, sir.
Okay. Now I'm, yeah, where am I?
Again, new share.
Okay. Now it's okay now?
Yes, sir. Yes, sir.
Okay. So now, after, I hope now, this is a wonderful, training session or that is going on. But if you attend these conferences, you will get what is happening recently in the area of machine learning, data mining, and everything. So this is my research area, actually. Stop share. What is this? Why this is coming?
Which one, sir?
The top something you are screen sharing, the instruction is coming.
That is true, sir. Just and it means you are sharing your screen only say information, sir.
Okay.
Because even we are getting that one, sir. Because your name is coming, it means you are the person who is sharing.
Yeah. Okay, just a minute. I can. Okay.
Now it is visible, sir. Complete.
Okay. That's okay. So my research area, actually earlier I started with database systems. I worked on transaction synchronization, database system, database recovery. Later I moved to data mining. So in data mining, I'm just working on frequent patterns, pattern discovery and classification, clustering. And also in parallel, I'm trying to extend the developments in database system and operating systems to build the systems to help the farmers. So as a part of that, I built several systems. Today, I'm going to share the experiences of building of those systems. This is my future research plan, actually. So with this, I will move forward. The outline of this talk is as follows. So I will just first motivate. We will spend some time. So I will motivate everybody to work on these kind of problems. So I hope after this motivation, and everybody will be in a position to find a research problem. That's what I'm just proposing. So I hope it will happen. So then I developed ISAGU, low-level ISAGU, and these are the systems to help the farmers. Currently, I'm developing a crop darpan. I'm going to share the experiences, and then I will conclude, actually. So what is happening here? Okay. What is happening? Oh, this is talking. This should not appear because it is blocking. Okay, sometimes it is appearing.
Which one, sir? Top one, sir.
This you are screen sharing. This is blocking my actually thing.
So that you can slide to some corner place, sir.
It is not going. Okay. Yeah. Okay. Just a minute, I will try to stop and then I will share again. Huh? Okay.
Yes, sir. Yes.
Just a minute.
Otherwise, sir, hide this. Sir, you right side, right button, click it, sir. There hide screen option
Yeah,
is there, sir.
yes, I will see. Just now, let me see.
On that, right click.
Okay.
Yes.
No, one thing is, it is not going. Somehow it is.
So, sir, you come to that you are viewing the Krishna screen is there, no, sir. You come to that and you click on the right button of the mouse, sir. Then you will get top one, some hide screen, something you will get, sir. Hide option, something. Very first option.
Okay. That is my thumbnail is adding, not. Okay. So let me continue. Actually, I thought that this.
We are not getting, other members are not, a few members are not getting.
Yeah.
Sir.
Either it is going on the top or it is going on the top bottom. Okay.
Now it is visible, sir.
It is visible. For you, it is visible. Okay. Okay.
For you, it seems, is it obstructing, sir?
So I'm worried that whether you are
it is clearly visible for us, sir.
Okay.
Yeah, it's the top, title is developmental challenge.
Yeah. Okay. So, okay. So, okay. So, let us see the development challenge we are facing. So, you see the left-hand graph. So, this graph shows percentage of population earning less than $1 a day. So, in the US and Europe and Australia, about 2% are earning less than $1. I mean, they are very rich countries. Whereas in Africa, everything, the other countries, there are 61 to 80%. Let us come back to India. India is kind of, this is 2009, India 41 to 60% earn less than $1, about 100 rupees a day. So this is the root cause of all problems, all Indian social problems. So this less earning is leading to illiteracy. They don't go to school. And also they don't get the skills. As a result, they don't get employment. And they don't eat well. So as a result, they fall ill actually. So less earning is leading to all problems. So the challenge before you and me is how to bring this population out of poverty. So the opportunity. So the point is that almost all have mobile phones, but most of them are having smartphones. So this mobile phone and smartphone revolution is due to this revolution. So now we are able to connect each and everybody in India, most of them. So also another advantage, another important phenomena is that the mobile phones are increasing with capabilities. So the capabilities of mobile phones are increasing year by year. More main memory, more CPUs, more cores, and cost is also not significantly increasing. So overall, this provides us an opportunity to explore massive mobile-based systems by exploiting this mobile phone phenomena. So let us see. Just a minute. Yeah. So what should we do now? Where is an opportunity? So the opportunity here is that IT plus livelihood technologies. So if you see left-hand side, these technologies are useful for society. We have agriculture technology, education methodology, medical technologies, artisan technologies, employment generation, resource distribution, and efficient governance. If you see right side, this is our characteristic of our Indian population: rural and urban poor, uneducated farmers, unemployed youth, undernourished incomes, undernourished people, and having little incomes. Earlier, there is a direct connection here. So there are over centuries, people are making efforts to, the governments are making efforts to, push these livelihood technologies to population. The new phenomena is information and communication technologies, which may call it data science, machine learning, whatever it is. So we got internet, mobile networks, decision support systems, parallel access, online access, information service frameworks, cloud, big data. You can put anything here. For example, your data science, machine learning, and everything, networking, web, all kinds of things you can put. The research challenge here is that, can we use these ICTs to improve the performance of these technologies? So that's where you get the real research problems. So the answer is yes. If you say that, is it possible? Answer is yes. So you are a computer scientist. You know your programming languages, database systems, expert systems, sensor systems, whatever it is, whatever you know, you are expert: image processing, video processing, and everything. And these domains have a lot of problems. Agriculture has a huge area, medical domain has a huge area, education, huge area. So if we improve, if there's a possibility to improve, we have to improve it. The question is how to combine these two and to improve the performance of this population, to bring more benefits to population. Then when you can ask me, what can I do now? The question is that I am a computer scientist. I know only my computer science area. And how can I talk to somebody from agriculture or education? So there are two things you can do. First, you should be expert in your own area. So you should know, if you are a database researcher or machine learning researcher, you should be expert in your own area. Then what you do is that you have to identify one person who is having interest in solving research problems. Then somewhere the collaboration should happen. You may read some high-level papers from the other domains. They may also read high-level papers from ICTs. Then meeting should happen. So you should understand the life cycle, the work process life cycle of their systems, how agriculture functions, how medical domain functions, how treatment happens, what are the problems of doctors, what are the problems of pharmacist, how a new drug is made, all kinds of bioinformatics, all those things actually. So after identifying one collaborator here, then a few meetings should happen. Then things will start progressing. So with this, there will be number of problems actually. There are number of problems. Each area there are different conferences, different journals are being conducted. You can go through those journals. You can go through those conferences and try to identify some problems and start solving. So I hope you are going to find several problems. The interesting point here is that this box, these ICTs, this can be replaced with mechanical technologies, civil engineering technologies, chemical technologies, whatever. Then you can find a lot of problems. So this box can be changed. In this way, almost every domain can have a research problems. And if we solve those research problems, especially pertain to India, and we can achieve significant growth. So the question now, how I started actually. So how I started means that, for example, 20 years back, the database system, somebody might have taught database system, they might have used the book by Korth, actually, Korth and Sudarshan. So Korth actually. So he has published one paper and in 20 years back actually. He said that what is the research agenda of database researchers? So he said that at the time we have built operating systems, we have built database systems and everything. What should we do next? At that time, web is appearing just actually. So he said that one of the research agenda was creation of personal information systems. What is the personal information system? The personal information system pushes personalized information to each and everybody continuous manner. So he said that in future, that is what happening. Everybody will have a personal information device. Nowadays, we are calling a smartphone or PID or your iPad, whatever it is. So a PAS is tightly integrated with individuals' activities from morning to bedtime. So if everybody has a mobile phone, now can you build a system to improve, to push that information which is required for that individual? For example, as a pharmacy shop owner, he wants to know information about where the bulk discount will be provided for the drugs. As a professor, I want to know, I want to teach tomorrow class, and where is my some presentation slides or some videos, some information system should push me. So in this way, I report what I want. The system also should push only that information to me. So the building a personal information system is a huge task. For example, today I want to go to garden now. I want to know whether it will rain there or not. So this kind of specific information. For example, Google cannot provide this personal information. If you type a keyword, it will provide the same information to you, and it will provide the same information to me. A lot of information is pushed to individual, but personal information system only pushes the information which is required for that individual. It doesn't push unnecessary information. So the point is that so a mobile can access internet everywhere and anytime. The main issue is development of personal information system to provide agricultural advice for each farm, to provide veterinary advice for each animal, provide health advice for each individual, provide literacy to each individual, empower and provide employment skill to potential population. I think all these problems are research problems. We have not built systems actually. People are making efforts. So now I posed a question. So since I am from the farming community background, I posed a question. What is the personal information system for the farmer? Okay. So when I was doing postdoc in Japan, actually in before 2002, so I read that paper. I said that what is the personal information system for the farmer? So what should be what farmer needs? Actually, every farmer cultivates some farms. Okay. So every farmer cultivates some farms. So each farmer requires the information to improve the productivity of that farm. For example, I have sown a cotton crop. I might have sown a maize crop, or whatever it is. Normally, farmer doesn't know what to do in that farm, whether he is missing any steps, whether crop is facing any problem, whether crop is requires any fertilizer. So the point is that if somebody tells him that you are doing fine, you have to do the following step continuously, maybe every 10 days, everything, I thought it will help him. So the point is that, so I posed a question, the stakeholder, I'm a farmer, what I want. So I'm a farmer, what I want. So who is the farmer here? The farmer is a typical farmer in India. If you are a typical farmer of India who are 2 to 3 acres, mostly you are illiterate. Even though you know how to read and write, don't take it that seriously. For example, even though I am literate, I don't know about agriculture. So that is a different matter. So I just posed a question, what farming needs? So farming needs water. So everybody knows that without water you can't do it. The water problem should be solved, but this is the kind of government should make efforts and to build the dams and harvest water. So I have not taken that research issue. Second, farming needs finance, investment, and also government should make efforts to provide finance to each farmer. So I took third issue. The third issue is that farming needs knowledge. So I said that this is the main difference. I said that each farm of India, each farm is a 2 to 3 acre plot. Each farm of India needs knowledge to reduce crop failure and low income risk. You see, you got millions of farms. What I'm talking, each farm of India required some knowledge. Whatever the knowledge, whatever the steps the agriculture scientist recommends to reduce the crop failure and low income risk, occasional risk. What are we doing now? We are not doing farm level advisory. Now also we are not doing. What are we doing? So from the government side, from the other system side, we are not doing the farm level advisory. What are we doing? We are doing generalization. For example, we have got excellent research system like Indian Council of Agriculture Research and agriculture universities. But the problem is that they don't provide knowledge at the farm level. The knowledge is not reaching the farm level. So the existing systems are generalized and pull-based. Generalized means that now what they are doing now, they are having a call center. For example, the call center means farmer has a problem, he has to call. Okay, but not a lot of farmers are not calling. The other thing is that you got a radio system. So radio system, what happens? You give one speech, you expect that all are listening. So it is a kind of generalized push-based system. So another thing is that TV program, half an hour TV program you run. Another thing, you build a website. Website is also, you expect that farmer should visit the website and you take the steps. Most of the times, you know what happens, farmer might be facing different problem, and farmer might be facing different problem, and more of the knowledge you are providing may not be relevant to him. So the criticism of existing systems are, they are generalized and pull-based actually. So overall, recording on radio, show names of annotators, ID video panel. Okay. So overall, what is the problem? We have agricultural knowledge dams. Knowledge is there somewhere, and these knowledge dams, I call it, agricultural universities and research labs. And we do not have knowledge canals. We do not have knowledge canals. So, for example, if you have a Nagarjuna Sagar dam, you forgot to dig the canals. What will happen? Water will be useless. Similarly, we got a valuable knowledge with agriculture universities and research labs, but the farmers are not getting that knowledge whenever they require, whenever it is needed. So the research problem is, so we do not have knowledge canals. So I posed a research problem like this: how to build a knowledge canal to deliver actionable agriculture knowledge, actionable knowledge to each farm in a regular manner. So the problem is very loaded question. What I want to do is that in all over India, there are millions of agriculture farms are there. Can we build a system to tell the farmer what he is supposed to do for each farm of India separately? So each farm requires a different knowledge. That with that kind of assumption, this question is being posed. So now you can ask me that why are you posing such a question? Is this question is relevant? Is this question relevant? So the question now, if you observe carefully in the society, last decade, what is happening? Even last 2 decades, we are making efforts to provide literacy to everybody, education to everybody, roads to every family, every house actually, drinking water to everybody, skill to everybody, employment to everybody. We got 100 days rural employment guarantee program that is running, Mahatma Gandhi rural employment guarantee program. So the point is that what I'm saying, the personalization is happening in other domains, in the field of education, in the field of road connectivity, in the field of drinking water, skill, everything. What I'm saying is that why don't you build a system to push a knowledge to every farm? Whatever the cost, for example, for providing employment, you are having a huge thousands of crores are spent to provide employment, 100 days employment. So I will show you that if you just spend a minute portion of that funds, I can build a system to deliver knowledge to every farm of India. I can give you more returns actually. So that's what I did last 20 years. I demonstrated that it is possible to build a system to deliver actionable knowledge to each farm of India. So, provide knowledge to each farm. What is the advantage actually? The advantage is significant. Providing knowledge to each farm will create multiplier effect. Multiplier effect means if you provide a knowledge to each farm, it will reduce the investment. It will reduce the unnecessary pesticide sprays, fertilizer bags. Also, it will improve the yield. With that, what happens? Farmer will get more income. As a result, his health problem will be solved, or poverty problem can be solved. So the point is that you have to solve that problem. If you solve that problem, other problems should be solved automatically. So you should not make effort to solve all the problems. You should solve the core problem. What I'm saying is that solving the knowledge problem is the core problem. Once you solve the core problem, other problems will be automatically solved, should be solved. So another thing is communication is not a problem. Because of development in communication technology, the communication is not a problem. The question is that, so with this availability of mobile phones and everything, how to build a system to deliver actionable knowledge to each farm? So in this connection, this is the background of the problem. I am building 3 systems actually. I'm going to give you a review of those systems now, overview of those systems. So if anybody has any question so far, I will take it actually. What is this? Yeah. So, okay. So anybody has a doubt? Yeah, chart, somebody asked doubt. Yeah, court book. It was a court book. I want to take questions if anybody has, otherwise I will resume, okay? Okay, I'm going to resume the talk now.
Yeah, dear participants, if you have any questions, always immediately post the questions in the chat so that it will be easy for sir to answer. As in when you get any sort of questions, please post the questions immediately in the chat box.
What participants should do is that they should criticize the talk. It is not only listening. They should identify mistakes actually, because I'm just, this is the kind of provocative talk I'm giving. So it is not about typical survey of data mining, survey of machine learning, something like that. So it is already, I'm posing some kind of new problem. So you should pose some doubts actually. So everybody should have their own view. Okay, please share your view. So now what I'm going to do is that this is the research problem. What is the research problem? How to build a system to deliver actionable knowledge to every farm of India. In this connection, first I conceived a system. I conceived an idea of ISAGU. I built a farm level system. Then I had some issues with those systems. So because so you make some assumptions, you build something. Then I refined it with village level ISAGU system, which I am happy with the village level ISAGU system. Then by considering the futuristic situation, by exploiting smartphones, I'm building a crop darpan tool now. So I'm going to share these, details of these systems. E-sagu means Telugu word, E-sagu. Sagu means cultivation in Telugu language. Sagu means e-cultivation or e-farming. So about E-sagu, E-sagu is an IT-based farm-specific agro-advisory system. So before building a system, I wrote the objectives of this system. Okay, what this system should do. So I'm a farmer. So suppose I'm a farmer, what I want? So I want the system should provide expert advice to each of my farm. It should be personalized. I don't want saying that other farmer is receiving the same advice, I have to copy. No. I have got farm or N farms, some 10 farms. I need 10 slips every 10 days from the system. Each slip should contain what kind of steps I should take to improve my productivity. What kind of pesticides, what kind of fertilizer, whether I should do anything or not. The advice might be that you are doing fine, don't do anything. Okay. So it should be personalized, provides personalized agro advice to farmer doorstep. So the question is that I should not ask any question to the system. Without me asking any question, system should provide the answer. And the difference between the problem occurrence and delivery should be less than 24 to 36 hours. It is not that I have a problem, crop problem, your system will reach me after 10 days. That should not happen. Also, the system should provide advice regularly. For example, every 10 days. So from the sowing to harvesting, the system should give a slip to me. Slip means that advice slip to me once in 10 days. And also, the system should provide if you are providing one advice on Monday, next week advice should be based on the feedback of this advice. It is not one-way pushing. It will be two-way talking. Also, the system should not ask any question from me. As a farmer, I am a very busy person. I don't want to ask any question. I don't have time to ask a question also. I don't know how to ask a question. That's the point. Most farmers do not know how to express their problem. I hope you know, you are also from the rural background. Most farmers, they don't know how to express the crop problem. They say that something crop is not doing good. I'm going to solve that problem also now. So overall, it should be cheaper and it should be powered by IT. It should be scalable. It should not be difficult to develop. We started in 2004 and overall we developed actually. So what is the basic idea? So the basic idea is that in medical domain, a doctor examines black and white X-ray and detect the human health problems. Okay, so that is clear to us. So normally when we have some accident or something, some internal damage to individual, we go and immediately first step is X-ray. With X-ray, he neatly identifies the problem and recommends operation or whatever it is. So I posed another question saying that in agriculture domain, why cannot agriculture expert examine color photographs and detect the crop health problems? So here, so it should be okay. So this I posed in 2004 actually. So the overall, the idea is extend the developments in IT to agriculture. Okay. So the overall idea here is that agriculture scientist does not visit the crop. Okay. Crop photos are bought to agriculture expert. So, so it means what is happening here? Earlier, what is the innovation here? You can ask me, so what is innovation? I will tell you what is innovation. Earlier, if you want to provide the advice to the farm, the agriculture scientist has to walk to the farm, or you have to travel to the farm, you have to have your own vehicle or bus, you have to visit the farm, see the farm, deliver the advice and travel back. Normally, agriculture expert stays in the city, the farms are in the rural. Okay, so it's a significant effort. With this, what I am doing, scientist is not moving, the farmer is not moving. In between, there is a communication technology like mobile phone or web. So what is happening? The farmer is not seeing the crop. Scientist is not seeing the crop. Instead of scientist, somebody else is seeing. Maybe farmer is seeing and taking the photographs. and the photographs are transmitted to agriculture scientists. The agriculture scientists see the photographs and deliver the expert advice. So in this way, what is happening here? There is no movement here. Only information is moving. Instead of persons, only information is moving. So moving of information is cheap and faster rather than person. So, and again, the task of giving expert advice is distributed. Earlier, scientist alone is going to the crop, seeing the photographs and delivering expert advice, coming back. Now scientist is only sitting one place, with the going to the crop is replaced by internet. Seeing the crop is done by farmer, and capturing photographs done by camera. So again, so he's seeing that the farmer is acting as the extra eyes of the farmer, extra hands of the, farmer is acting as the extra hands of the scientist actually. With this, the task is distributed. The task is distributed, then we are having a benefits of distributed system here. So what is a distributed system? Distributed system is you distribute the task. Things should happen. So in this way, with the single idea, there is a asynchronous and distributed system phenomena we are realizing. As a result, this should work. This is scalable because you can keep on increasing scientists as number of farms increase. There is no problem. Now also, this is a little bit asynchronous, non-real time. We are going to discuss more actually. So I reported these ideas in this paper. So as a result, the agriculture expert can utilize the time efficiently, spend less time to provide the advice, can work during the night. Okay. So yeah, so this is advantage clear. The question was that again, so there's a lot of, it took about 3 years to launch the project actually. Then, this is the societal project. So social science project, you can't make a lot of assumptions. So we assume that farmer will send the photograph. Farmer cannot send the photographs. But what we said, if farmers are capable, they can send the photograph. It's difficult to implement as several farmers are illiterate and cannot send the photograph. But what we did was that in every village, we can have some educated farmers who are brought in as coordinators who will take the photographs of farms behalf of the illiterate farmers. So overall system is as follows. This is the ISAGU main center, agriculture experts, agriculture information system. This is the communication system. This is the ISAGU local center. A person, coordinator house can be a local center. Each coordinator C manages certain farms. So this in this way, this happens in the village. This is in the village. This is in the city, somewhere, anywhere. This may be agriculture scientist house also. Here, this might be anywhere in the cloud system kind of thing. So it is a massive distributed system. Coordinators are anywhere, their houses. Agriculture scientists can be reside in their houses, and your system will be deployed in the cloud. So everything is interacted with the communication system, internet, courier, or telephone, whatever it is. So in this way, this massive cloud-based distributed system can be built. So how things are operated actually, how this functions. So operational procedure as follows. First, what will happen? The coordinator who is in the village registers the farm. He'll go to farmer. Then he file water, capital, crop details by consulting the farmer. You go to the farmer, you take the soil, water, capital, crop details. This is a one-time information. After that, once in 10 days, so coordinator visits each farm once in 10 days. Okay, coordinator visits each farm once in 10 days and takes photographs, problematic photographs. What photographs have to be taken? Again, agriculture scientists will say there are scouting methods in agriculture. Scouting methods determine how to see whether certain pests exist or not. So it takes problematic photographs, fills in observation cum feedback form and takes its photographs. So he also fills in observation feedback form with a pen and takes its photographs, uploads the data into ISAGU portal. So advice preparation. Agricultural scientists prepare the advice based on photographs and other information. So by seeing the photographs and they prepare the advice. So I'm going to demonstrate the system. The coordinator delivers the print advice to the farmer. After delivering advice, he will download and deliver the print advice to the farmer. This happens once in 10 days from the sowing to harvesting. So this is the photographs. So think that I'm a scientist. This is the photograph. This is the first photograph. For example, if I click first photograph, yeah, this is the first photograph. So it's a long shot, the cotton crop. I assume that I'm a scientist. So then it's a zooming kind of thing. Okay, it's a zooming kind of thing. Cotton crop. So scientists will get how the crop looks by seeing the photographs. Now this is the close photograph of the leaf. Okay, close photograph of the leaf. You see zooming. This is the zooming. Okay. So you see here, if you zoom this is the kind of thing. So coordinator sends this photograph. Coordinator sends this photograph. Scientist will zoom it. You will get this photograph. Okay. So what do you mean actually here? It means that zooming facility is providing, giving clear picture of the crop. So zooming facility is creating a confidence to a scientist. It is as though scientist is looking the crop through microscope. Okay, it is as though scientist is looking the crop through microscope. So actually, when I started this system, what happened was that I got this idea. I submitted a research project proposal to Government of India. I said that I'm going to implement this system for 1,000 cotton farms in Warangal district. At that time, we started a lab in IIIT, which consists of 5 scientists and coordinators, administrator, and everything. Then we hired the 20 coordinators, 20 cameras, 1 computer system, local center, everything in nearby Warangal Urugonda village. Then we built a system and we started operating it. So the coordinators are sending photographs and I'm observing how scientists are giving advice. Then I was skeptical. I was skeptical means I don't know whether system will work or not. Because scientists say that they can't deliver the advice. I can't do anything. Okay, I have to close the project. So then 2-3 weeks I waited. Then I talked to scientists saying that I asked him. So the entire project is based on the assumption that scientists can see the photographs and deliver the expert advice, isn't it? If they say they can't deliver the advice, I can't do anything. So I can't force them to give advice. Then I talked to them. They said that, sir, the zooming facility is helping them to give the advice. The zooming facility is helping them to give the advice. The zooming facility is helping them to observe the leaf closely, as compared to more closely as compared to the observation they would have made by visiting the crop. So at that time, I was very happy our system will function. The point is that scientists also have their own background. So by seeing the crop, they can deliver the expert advice. And this is the third photograph. You see, the stem is becoming black, and this is a zooming of that. And this is the feedback form. You see, so the coordinator writes the feedback form. You will have a pen and paper. So Raju and Kamlakar put on up 55 to 55, and Kandam Nallalaga stem is becoming black 50%. 3 acres 100 kg యూరియా చెట్టుకు అతి దగ్గర వేయడం వల్ల ఇలా చెట్టు మొదలు వాడిపోతుంది అనుకున్నాడు. So he will write, he will scribble whatever he wants by talking to the farmer or his observation. So this entire photographs and feedback form comes to scientists. Okay. So this is the advice that is given to the farmer. Okay. It is not due to fertilizer application. So the scientist is writing. It is not due to because the stem is becoming black. In the feedback form, the farmer wrote that it is due to fertilizer application. You might be thinking farmer perception is different. because farmer is not a scientist. So the critical scientist saying that it is not due to, problem is not due to fertilizer application. It is a root rot disease. It is a root rot disease. To control this, pour copper oxychloride 3 gram per liter or carbanism 1 gram per liter solution at the base of the infected plant immediately. Okay, to control this, pour copper oxychloride 3 gram per liter or carbanism 1 gram per liter solution at the base of the infected plant immediately. Then mix 2 kg trichoderma formulation in 50 kg FIM, Pasula Eruvu, and sprinkle water on this mixture to maintain the moisture and keep it for 15 days and then apply in field along the crop rows. Okay. Tell the farmer to apply 75 kg potash in 3 acre land as early as possible. So this piece of advice goes to that farm within 24 to 36 hours. In this way, if you visit that farm on Monday, next Monday you have to visit that farm. The coordinator has to visit that farm. In this way, every farm receives expert advice once in 10 days from sowing to harvesting. This is the second day. So what happened was that the first year was very successful project, and 1 year we operated in Warangal district. Government was very happy. They sanctioned another project. Why don't you scale this to 5,000 farms? So this one, we at that time we implemented in West Godavari for rice, 3 villages, and Thandoor, near Thandoor, 3 villages for red gram crop, Mahabunagar, 3 villages for castor crop, Anantapuram for 3 villages for groundnut crop. In this way, again, Khammam, 3 villages for chili crop. In this way, massive project was run. At that time, 100 people used to come work on this project. So brown plant hopper, sheath blight, and neck blast. So this is the photograph taken from West Godavari. So here, zoom in, zoom out. So this is the problem. Brown plant hopper spray, ethylphenofrox 300 milliliter, imidacloprid 600 milliliter per acre. Sheath blight, hexaconazole 400 milliliter per acre, or propiconazole kind of thing. Neck blast, either incident is low, no need to spray. So no, drain out water and maintain thin film of water. Direct the spray towards the base of the infant plant. So this kind of advice goes to the farm. These are some photographs we collected, kind of thing. So then government told me to implement. Why don't you implement for fish? So fish, we have done it. So we have selected one village called Patepuram village in West Godavari district, and we operated fish actually. ISAGO IT-based personal agro system actually, this one. So for fish, we have to, so in that village about 200 ponds are there. All are ponds only in that village. There is no land here. So what we do that there is a coordinator plus boatman. So coordinator goes in the boat and catches fish, and most of the problems are fish problems are expressed on the skin and gill actually. Okay, so they catch some fish and open the gills and take the photograph, leave the fish in the water. So in this way, also they measured ammonia, pH, ammonia. There's the meters we have bought, watercolor, everything. These observations, and these are the some of the this one actually. You see. So these are photographs. This is advice. You see, you are looking at flukes and reddies at the starting stage. Apply BKC 80% half liter per acre. Supplement endofloxacin half gram per kg of feed. So the point is that this is the fish scientist. I recruited some fish scientists, and they gave this advice. So the fish also, it worked actually, and that has a different experience. It has a different experience, completely different experience, and then. Because again, in the beginning, nobody liked this system. Then after delivering advice, everybody came and saying that this system is providing good advice. So in this way, fish farmers, mostly educated farmers, they felt that the system is helping them. So this is another thing. So you see symptoms of trichodina. This is the previous advice. This is the photograph. Symptom trichodina. Ask the farmer to apply Nuvan half liter per acre. Ask to reduce the feed for 3-4 days. So in this way, this fish farming, ISAGO for fish also has been implemented, and it has worked actually. So then we conducted impact evaluation study. So what is how to do impact evaluation study? We selected some villages where we provided ISAGO advices. Then we selected other villages which we have not provided ISAGO advices. So this is called control comparison. In the beginning, we go and have some study. In the middle, we do some study comparing 3 villages of this, 3 villages of that. So finally, the impact evaluation report showed that for cotton, the per acre gain, the reduction in fertilizer, about 1 bag of fertilizer bag is saved, and 2.5 pesticide sprays were saved, and 1.5 quintal of cotton gained actually. About 4,900 rupees per acre, they got extra benefit, additional benefit. This is additional benefit. So because why this gaining yield means you are getting more flowers, more birds, all those things. You are reducing fertilizers because we are conducting soil test and everything, and also pesticides because we are giving advice every week, every 10 days. Normally, when problem is small, we are giving some low cost advice, and we are not allowing for problem to grow. We are not allowing for problem to grow. So that's the kind of thing. In case of chili, this is the kind of thing. 7,800, 8,000 rupees, and paddy 2,000 rupees, red gram 1,200, groundnut 1,200, castor 2,000, all these crops. So overall, about 4,000 average benefit farmer got actually. So in this way, so overall, the results show that farmers are happy with the advice. Farmers are happy with advice. It is encouraging integrated pest management and judicious use of pesticides. We are not saying no or yes. So we are saying that whenever there is a problem, you use the pesticides, okay, and fertilizers by avoiding their indiscriminate usage. So the farmers are following indiscriminate usage. For example, in West Godavari, at that time we observed that every 10 days there is a spray actually. Every 10 days. So for rice, to get the rice back, they use 10 to 12 sprays per season. So, these kind of sprays can be avoided with the scientific knowledge. So scientists, so under the advice of scientists, we can say that we can save the sprays actually, because farmer is very apprehensive. Farmer is fearful of the fact that the crop may go bad kind of thing. Okay. So the point is that this ISAGO is a kind of system is connecting agricultural scientists with the farmers and encouraging integrated pest management. As far as possible, integrated pest management means that as far as possible, don't use the pesticides like in neem and everything. So some organic methods we are encouraging, and if required, we recommend pesticides. Otherwise, no, I can't agree. Overall, the indiscriminate use of pesticide is avoided in the ISAGO. Actually, we are not allowing the problem to grow because, every 10 days we are giving advice. The problem cannot grow because scientists is following. So what is happening? Farmer is cultivating physically. Scientist is cultivating the farm virtually, logically. So as a result, farm will be protected. Gain is significant. About 3,820 rupees gain. 2004 impact evaluation study, 2005 impact evaluation study showed the 3,874. In this overall we got it, but every year we conduct impact evaluation study, we are getting the same results. The question now is that you can ask me, sir, you have built this system. How many? What is the number? So now in the third or fourth year of the project, I conducted a project throughput. Normally, when we build operating system, we teach operating system or database system, we say that how many transactions are executed per second. So I wanted to examine how many advices scientists can provide given 8 hours a day. So then we did experiment. We asked the scientists start giving advice at 10 o'clock, and then you continue, and then break for lunch for 1 hour. Then overall 6 to 6.5 hours is working. in 6 to 6.5 hours, he is clearing about 100 forms, 100 advices per day. It means that he is creating the effect of visiting 100 farms actually. So can you imagine scientists visit 100 farms? It's impossible. 100 farms physically impossible, because for movement only takes time. You can visit about 3 to 4 farms in the morning, 3 to 4 farms in the evening. In this way, the system is enhancing the capabilities of scientists through coordinators, of course. So within 24 to 36 hours we are reaching, and so we also charge the services, charge the farmers some charge, and they are also happy with the advice. So now this is the summary of the ISAGU. So overall ISAGU, you mean that the concept of ISAGU is that taking the photographs rather than visiting the crop, and also first time I was the person, I am the person, I proposed the notion of farm level advice. Farm level advice. So every farm needs an advice. This concept, personalization, notion of personalization was proposed by me actually. So for this, this system has become popular academically, and it has wide, discussion actually. Almost all scientists know about this. Government knows about this. But overall, I recommend ISAGU for normally the cash crops, cotton, mango, and chilies, and your orange and other crops actually, even vegetable crops also, because they require a close advice. So the question now is that so after doing the research, we have to deploy. So I had faced a deployment issue now. The point is that ISAGU system benefited all kinds of crops, input intensive, cotton, chilies, mango, very good benefit. But food crops, cereal and pulses, less benefit actually overall. So the point is that we did some data mining here, and we found out that most of the problems are farms at a given time. For example, if I deliver advice for 100 farms, about 80% of farms are facing the same problem, given time. But we observed that these 80% of problems are not facing the same problem next week. You see, the horizontal x-axis, some 80% of problems are facing one problem. Next week, they are facing different problem. Next to next week, they are facing different problem. So in this way, you can't say that, okay, these 80% of problems facing same problem this week, and they are going to face the same problem next week, because of different kind of things, soil conditions, how depending upon a farmer, the input is supplied to by farmer. So when we took this ISAGU system for deployment, so there are several comments. So overall, it's okay, system was okay, but overall they felt that this is little bit expensive. The farm level is difficult to implement, and also the farm level, the government and everybody, they said that it is difficult to implement. So still, I proposed the farm level ISAGU for anybody who is interested. Then I said that then we did something actually. Then I called all the farmers. So I did some experiments. So what government told me that, why didn't you collect money and implement your system? So you are saying the ISAGU is good, you collect money. Then I started this experiment. We collected money. So we collected money from the farmers. About I said that give us about 300 rupees per season per acre kind of thing. So we implemented in one village. So we had about for example 400 farmers in the village. So everybody paid in the first year. Second year they were not paid, about 50%. Third year it came down to 30 to 40 farmers. Okay. So the question is that about 30 to 40 farmers will pay, other farmers will not pay. So there are different socio-cultural issues why they are not paying, because everything else is free. Why you are charging this knowledge? Government should provide free knowledge, all kinds of things they'll say. Okay. Then I called them. I called them in the bus to IIIT. I asked them, why are you not following advice? They said that everybody is following your advice, sir. Only thing is that whenever we have problem, we ask the other farmers for which to whom you are sending advice. So we are going to copy. We are copying the advice from other farmers. Then from that I got a new idea, that is village level ISAGU system. So I said that this system should be developed such that farmers will not pay. Farmers will not pay. Somebody else has to pay, because it is very difficult to collect amount from the farmer. So we have to have a new kind of business models, like a Google. Google, who is paying to Google? Google is free to you, okay? But Google collects the money through advertisements. So Facebook model is they collect money through advertisements. Even LinkedIn, almost all web portals, they have other business models. So in my view, we have to have a different kind of business model to help the farmers. So with this, I started, again, I rewrote the objectives. So what I did for ISAGU, again, I said that, so this system which I'm going to build, I'm going to refine, should be accessible to poor farmers throughout the year, should cover all crops. Also should not compromise on personalization. The personalization was good, but it should not be a major compromise on personalization. It should be affordable and scalable. So even little bit money people want to collect, if they want to collect, they can, if they want to pay, they can pay. It should encourage community discussion. If people want to discuss with each other, they should encourage community discussion. So because the major criticism of ISAGU was that you are giving advice to farmer and he is not discussing with anybody else. So I said, so then I said that let us discuss. Also, the system should allow farmer to learn. So with these objectives, we started building village level ISAGU. The village level ISAGU, the small change. One physical notice board is kept in the village. One physical notice board is kept in each village. Coordinator is equipped with computer, internet, color printer, motorbike. Now his addition is color printer and motorbike. Earlier he was having computer, internet. We gave a color printer and motorbike. We formed the cluster. So we had a concept of global village. Global village means one major village surrounding villages. So we consider a group of villages as a single global village. We formed a group of clusters of 5 villages having similar farming situation. A global village and surrounding 4 villages. For each cluster, identify 30 sample farms. Okay. So then we extended the ideas from statistics, saying that if you provide the advice for sample farm, because the people are copying from the advice from other farmers, so we collect some advice for sample farms. So for each cluster, identify 30 sample farms. So 5 sample farms for each of the 5 major crops and 5 farms for other minor crops. Okay. So what we do that, for example, cotton, we got 5 sample farms: north, south, red soil, black soil, poor farmer, rich farmer. We got our sampling algorithm. So in this way, 25 sample farms are selected from 5 villages for major crops, top crops, maybe whichever crop comes. It may be banana, cotton, anything. So what happened that this is the kind of thing. These are a group of villages, sample farms are selected. The notice board advice will go to notice board. So one notice board, I'm going to demonstrate to you. So the capturing of farm data, the coordinator will go to only sample farms and collect the data. Okay. So sample farms are visited once in 10 days and problems are captured through digital photographs. So I'm not asking coordinator to go to every farm. I'm asking coordinator, he has a bike. You will go to the sample farms, maybe any corner of these 5 villages. You will go to this sample farm and capture the photographs. Okay. Then these photographs are sent to the ISAGU main lab, where a group of scientists will see and create advice summaries. The summaries contain photographs and advice. Summaries contain photographs and advice. Color photograph advice is these PDF files are, again, coordinator prints these PDF files and color prints these PDF files, puts in the notice board of the village. Okay, puts in the notice board of the village. Then the farmer should access the pictures in the notice board and compare his farm with the problem of his farm with the problem mentioned in the notice board. If they match, they have to follow. Otherwise, they have to call the coordinator to visit their farm. So once in 10 days, the farmer should get access to actionable advice to notice board, we send SMS to the farmer actually. So this is the notice board. We are going to show you. I'm going to show you more notice boards. So this is a sheet. Okay, you see, this is our thing. This is the village level notice board, and this is the coordinator number. Okay, so this is the cotton sheet or some other sheets are there actually. So this is a brinjal sheet. Okay. So in the brinjal sheet, what happens? The brinjal photographs, sample forms, 5 sample forms, bad photographs. This advice. So this sheet she is pasted here. Okay, each one sheet is like this. So like this maize sheet and paddy sheet. Okay, like this. So this is in the beginning of the project in the village, we had a very big meeting, and we announced that please, what farmers should do. Farmers should see this notice board in the village. So we'll place the notice board by applying majority algorithm. So we asked the farmers, give me 3 points in which at least you visit once. Okay, give me 3 points, at least you visit once. So in the majority, people will say that please put the notice board in that point. So we'll place the notice board there. So when he is walking in the morning towards his farm and coming there for shopping everything, mostly you will cross the notice board. So in this way, while crossing the notice board, suppose somebody is cultivating a brinjal farm. Suppose I'm a farmer, I'm cultivating a brinjal farm. So I said that your brinjal farm advice is appearing every 10 days. So every 10 days, the sheets are changed. Okay, the photographs are captured, sheets are changed. So can you tell me why the farmer will not see the notice board? If he's not seeing the notice board, mean that something is wrong with him. Because what notice board contains? Notice board contains the current photographs of the sample farms and advice. So if you are cultivating a brinjal farm, as for the probability theory, most probably you are also facing the same problem. The 80 to 90% chance that you are facing the same problem. So you copy this advice, go to pesticide shop and save your crop. If you think that you are having a different problem, you come to this notice board, there's a coordinator contact is there. You call him, he will come to your farm, send the photographs and get the advice next day. In this way, so what is notice board solution? In the ISAGU solution is 100% push. We are pushing the advice to each farm. Okay, in the ISAGU. Here we are pushing the advice to village level, village gate. From village, farmers should pull from the notice board. So 80% to 90% push and 10% pull is happening in the village level ISAGU. And also here the pictures are displayed, color pictures are displayed. Color printers are displayed. It is 2 rupees, 1 rupee per page is appearing. This is not that expensive. This picture, even illiterate farmer can also understand what is happening. A picture communicates more information than the text. So this is, I like this one. And you see maize, paddy, banana. This actual Telugu is happening for English for the demonstration purpose, for presentation purpose. Actually English, we have to run in Telugu. Crop banana, సిగటోక ఆకుమచ్చ తెగులు ఉన్నది, మ్యాంకో చెట్టు ఇది కవచ్ లాంటి మందులు. We are having a brand name also. So this is chili. These are the సూటి ఎరువులు వేయండి, సూపర్ దుక్కిలో మాత్రం వేయాలి, పైపాటుగా వేసిన మొక్క తీసుకోదు, ఆకుమచ్చలకు ప్లాంటమీన్. This kind of advice are given. You see మామిడి, మ్యాంగో, జింక్ బోరాన్ లోపం ఉన్నది, జింకుతో కూడిన న్యూట్రియంట్లు ఇవ్వండి. So the Jamikunta, there is a system Jamikunta, KVK Jamikunta. They implemented. They are very happy actually. So this is actual notice board. Actual notice board also being refined over 2-3 years of project. So this is the notice board. You see the BDL sanctioned the project. These are the photographs. You see, these are the photographs. These are all sheets actually. Sometimes, you know, the number of crops are so many, we have to put two notice boards. Yeah, so sometimes, you know, you are having excess sheets. Each sheet one crop problem. So more crops, even they are pasted in the walls also. This system has worked excellently because what farmer has to do, he has to just visit the notice board. So the point is that what I'm saying is that there's a gold in that corner, you go and access it. I'm not telling you where is the gold. So in this way, it is increasing the farmer's curiosity. So some of the youth, we operated in about 100 villages. It is acting like a weekly magazine, like a Swati or some other magazine. They are curious what kind of advice is going to come. Some curious farmers. Also, there's a group meeting. What are we doing? What we are saying scientifically, these are the steps you have to take. So then, if the farmer is not following, we can't do anything. So the question is, from what we should do, we have to announce this kind of knowledge to every village every 10 days and years together, that this is the steps you are going to take. Farmer will listen and they will change their practices. Also, these are some of the things. So the question is now, what is this notice board? What is this notice board? Notice board is the scientist, actually, visualization of scientist. For example, if you see any domain, how many good teachers are there? Few good teachers. How many good scientists are there? Few scientists. How many good doctors are there? Few scientists, few good doctors. Similarly, there are few good scientists. So here, the village level ISAGU is visualizing the good scientist, visualizing the visit of good scientist every 10 days to every village. So some of the farmers said that the notice board is nothing but face of the scientist. For example, Professor Narayan Reddy was the scientist, and he's saying that they are seeing his face in the notice board. Notice board, every 10 days the knowledge is being changed. Also, SMS is being sent to every farmer by saying the notice board has been changed, please see. In this way, so now once the notice board channel, this is called village level canal. I was saying that in the introduction, farm level canal, village level canal. This village level ISAG with a village level knowledge canal. Farm level ISAG with a farm level knowledge canal. Okay. So in this way, we have to have a canals, these kind of canals, where the knowledge has to flow continuously to each village. Knowledge has to flow continuously to each village. So, again, let us see what is the cost actually. What is the cost? I told you already in the ISAGU, saying the scientist can clear 100 advices per day. Now, coordinator can visit 5 villages, 25 farms. Suppose he takes photographs of 5 villages one day. Then I'm saying 10 days a week. So he can cover 40 villages actually. Okay, 5 villages, then 40, not 40, 20, because one day collection, one day display. So I'm giving 5 villages 2 days. So 10 days a week, 8 days, 20 villages covered by coordinator. But my scientist is clearing 100 advices per day. It means what? It means a scientist is advising about 100 villages, means that scientists under scientists, you can manage 5 coordinators. Okay, you can manage 5 coordinators every day. So the question is that if you have a 20 to 30 scientists or 50 scientists, I can cover entire Telangana. I can give advice to every village every 10 days and throughout the year. Now, not only this advice, I can give you planning advice also. And it is color advice, and every farmer will understand what is going to happen. So overall, the cost is, if you can manage about 50,000 per year per village, I can manage this notice board, including scientist cost including advice, coordinator cost, including system maintenance cost. Okay, that is the cost effectiveness of the system. Then the next is remaining time. I'm going to explain crop darpan tool. This is the one research project we are executing. This is the 4th year actually. Data science based farming support system for sustainable crop production under climate change. So this is the Indo-Japan joint laboratory research support, and under this we are doing research in 6 categories: efficient knowledge transfer, mobile based systems, personalized knowledge transfer, diagnostic databases, everything. So somebody is heading optical crop management, high performance breeding. So the IoT field sensors, different group is managing, database for big data, AI deep learning. So I am heading this wing, efficient knowledge transfer. As a part of this, I am planning to build crop darpan system. So the point is that again, whatever we say, same thing. So I already told you in the introduction. Majority of the farmers in India are not acquiring actionable agriculture information. So that is true actually. So the point is that the government is saying that government is running call centers and web portals, but the farmers are having perceptual problems. Okay, so there are communication difficulties, perceptual difficulties, explaining difficulties, cultural difficulties. So on the other hand, the radio, video, SMS, and voice-based services push generic information to farmers. Okay, high-level information. So there are 2 kinds of information system. Okay, one is actionable information. What is actionable information? For example, if you go to doctor, say that you are having a headache, you will give a medicine. The medicine that is actionable. Okay, immediately you can go buy and consume it. So the radio-based systems and video-based system, everything, they say that if this occurs, do this. If this occurs, do this. You don't know whether the problem is occurring to your farm, whether you have to buy the pesticide and do it. That is not actionable information. This is called generalized information. Okay. So again, the farm system like ISAGO, I have told you, they are having scalability issues. Scalability issue means if you want to have thousands of farms, then you will have some problems. So scaling the problem, but village level ISAGO solve some problems actually. So in this context, we are planning to develop a field diagnostic guide called Crop Darpan by exploiting progress in data science and mobile phone technology. So overall, the existing system can be categorized into 3 groups. Pull-based systems. Several farmers are unable to ask the question. The government is running. Push-based systems, ISAGO farm level system. Farmers are liking, but overhead is a little bit high. Hybrid systems, village level system. So that push and pull, 80% push, 20% pull. So what is happening in village level ISAGO is the notice board people are coming, but still they are again calling us, because whatever you say, village level ISAGO, in the farm level ISAGO, we are giving advice to each farm. Nobody, so he confidently goes to pesticide shop and take the pesticide and applies it. But in village level ISAGO, is the job of the farmer. Farmer has to see the notice board, compare the notice board problem with his problem, and act on it. So that is also not effective, because they are again calling us. Most of them are going to pesticide shop, calling our scientists saying that, sir, I have the same problem you display on the notice board, please advise, kind of thing. Then, so it means that from village level ISAGO, it means that farmer is able to identify the crop problem, the symptoms of the problem by seeing the photographs. With this hint, we started building in this motivation. The motivation of this project is that in future, now also it's happening, in future, most of the farmers will have high-end mobile phones with internet connectivity. Also, more number of educated farmers. Okay, this is true. If this is true, we posed a question, how about building a smartphone application to guide the farmer to identify the field problem and get the solution? How about building a smartphone application to guide the farmer to identify the field problem and get the solution? So how to do this? So this is a www.cropdarpan.in kind of thing. I'm going to demonstrate that one to you. So farmer possesses a smartphone and visits the farm. Okay. Farmer possesses a smartphone and visits the farm. So then what it does is, just a minute, farmer. So after seeing, so what I'm seeing is that, what I'm assuming that farmer with the smartphone, he visits the crop. So, and while walking in the crop, he sees the crop and answers some questions posed by his cell phone. Then, so farmer uses the tool I'm proposing to help the crop problem. So the advantage is that farmer is able to form a question for either crop problem, empowerment, and capacity building. This is what we are planning to do. So how can we do that? Because so you know the concept of generalization, we are doing it. This generalization is applied database technology. The notion of generalization is extended to build such a system. Generalization is abstraction which enables a class of individual objects to be thought of generically as a single named product. It's perhaps most abstract, most important mechanism we have for conceptualizing real world. Normally, when we understand the real world, we use the concept of generalization. So this is the research paper. So for example, this slide is important. So this is the generic hierarchy over the vehicles. Okay. If there is a vehicle, there are three types of vehicles: air vehicle, land vehicle, water vehicle. Air vehicle can be plane, helicopter. Plane might be passenger aircraft, air freighter. A road vehicle might be truck, bike, or car. So the point is that now, if I am seeing some vehicle on the car, so suppose somebody calls me from the road saying that I'm seeing some vehicle, I don't know the name. So now what I tell him, okay, I will pose some questions, you answer it. Okay. So I will ask him, is it a air vehicle? Is it a land vehicle? Is it a water vehicle? So I am posing the questions. So the problem is that somebody saw an object in the road, on the road, a vehicle, some kind of vehicle, and he doesn't know the name of the vehicle. So I'm asking a question, is it air vehicle, land vehicle, or water vehicle? He will say land vehicle. Okay, then I will ask him, it is a road vehicle or rail vehicle? He will say road vehicle. Then I will ask him, is it a truck or bike or car? Truck means 4 tires or something like that. When we say yes, they will say it is a truck kind of thing. So what I am doing, I am capturing questions. I am posing series of questions to the person, and based on that, I am helping him to recognize the object. Similarly, here the crop darpan tool, while walking in the crop, poses a series of questions to the farmer. And farmer has to answer it with yes or no. Presence and absence of symptoms, we call it visual symptoms. Based on that, it will recognize the crop problem. So now, this is the kind of 20 question game. Okay, in 20 question game, we might be playing from childhood. Suppose you imagine some object in the room. I want to name that object, but you have to answer my questions. I will say it is round or square. You will say round. So I remove all the square objects. The color, black or white. Finally, I will say that it is a fan or something like that. So this 20 question game, what is happening? Somebody is asking a question. You are saying yes or no. Similarly, when farmers enter the farm through mobile phone, System will ask the questions. Farmer will see the crop and confirm it. This is the basic idea. So listen, so there is one wonderful paper written by this Steve Brasson. So so for example, I'm seeing three objects. One is this left side. Is it the chair or aeroplane? It's easy for you, isn't it? Easy to say with the chair or aeroplane because it's a coarse grained, easy for humans. But if you say, if I ask you, it's the finch or bunt. If the finch or bunt, it is difficult to say for you, isn't it? Because you don't know whether it's finch or bunt. Because finch is the kind of bird, bunt is the kind of bird. But difference between finch and bunt is a small color, eye color, or some neck color, or something like that. You don't know that. So the left side you can easily, it is different. You can say that it's a chair or a plane. But here it is very difficult to say. But if I ask the question, same question, yellow belly, blue belly, you can easily say. Okay. So what I'm doing, I'm breaking this fincher bird into their features, their questions, then posing the questions to you. This is how we do it. For example, so I'm posing the question. So I don't know the name of the bird. I say, is the belly white? Yes. Are the eyes white? Yes. This bird is a parakeet auklet. Okay. This bird is a parakeet auklet. So yeah. Is the beak cone shaped? Yes. Yes. Somebody saying yes. This is a question. Is the upper tail brown? Yes. Is the breast solid colored? No. Is the breast striped? Yes. Is the throat white? Yes. The bird is Enslow sparrow. In this way. Okay. So now what we did was that, so the overall idea you might have understood now. I want to build a system. I'm not going towards machine learning. I'm just going rule-based system. Okay. When farmer enters a cotton crop, the system, he is having mobile phone, he will access my system. I will pose him a series of questions. Okay. I will pose him series of questions and he will say yes or no. Okay. So we did some field experiment. We said that, okay, sample farmer perceptions. Most of the farmers do not know the name of the problem. You see, leaves are curling, the name of the problem. If you say this to pesticide shop owner, he doesn't know what to give. You have to say name of the problem. So what we did was that we did a crop suffers from several problems. Normally everybody knows. For a cotton crop suffers from 30 to 40 problems. A field problem is a combination of visual perceptions. Normally, whenever scientist goes, he identifies whether the leaf is bad, leaf has holes, leaf is becoming black, stem is becoming black. In terms of visual perceptions only, he will identify. So both farmer and agricultural scientists can provide visual symptoms for each crop problem. Okay. So the point is that based on the experiment, just listen carefully, the farmer identifies the crop problem with general visual appearances. Normally, you know, only leafy color is bad, some crop is not growing. He doesn't know detailed visual appearances. Okay. He doesn't know name of the problem because he is not educated. But agricultural scientists map the problem to a collection of specialized visual appearances. So here, this is the important slide. So what we said that the farmer said the problem is leaf curl. If farmer says that problem is leaf curl, it might be one of these problems. It might be white fly, aphid, thrips, mealybug, jacids, leaf curl virus, zinc deficiency. Okay. Then you see, for white fly to occur, farmers, the scientists see the following: presence of insect should be 1. It should appear in the crop. Insect color white should be 1, and also leaf discoloration should be 1. Discoloration scatter irregular 1. Black cuticle growth 1, like that. Similarly, aphid is the name of the crop problem. All should be 1. This insect color black should be 1. So insect color is black, it is aphid. And also this distinct one, this discoloration, scatter irregular, it should be white fly kind of thing. For example, here these are thrips. Presence of white or silvery spots on the lower head. These are thrips. So what is happening is that now, if you see these things can be posed as questions. For example, presence of insects. If you ask the farmer whether insects present or not, by seeing the crop, you will say yes. For example, insect color green. If you ask the farmer whether green insects are appearing on the crop, you should say yes. The question now is that farmer doesn't know name of the question, but if you pose a question, he will be able to answer the yes, because he has a thinking power. He can capture thinking actually. Okay. The question now is that each oriental symptoms can be posed as a questions. Can pose to the farmer sequentially some algorithm. Then he will confirm with the crop actually all those things. So just a minute. I'm going to see. Yeah. So are you see the screen? Do you see the screen? Hello? Hello? Are you able to see the screen?
Yes, sir.
Yes, sir. Okay. Okay, good. So now this is the kind of system. So you are in a mobile phone. You can access this crop darpan through mobile phone. Just try to access through mobile phone. It is available on site. We are developed for cotton crop. Everybody should access cropdarpan.in. Cropdarpan.in, I will show you. Just a minute. This is cropdarpan.in. This one. Crop darpan. You search for crop darpan in the Google, it will come. So there is some proceed security plan. You can proceed it. I hope everybody please use your mobile phones and access cropdarpan.in. Okay. So now I am taking this mobile phone and I am visiting the crop. Okay. I am visiting the crop. So I can say I can say Telugu. So now you see the system is okay. I want to know cotton. So I'm going to Telugu. So system will pose these questions. I hope you know. Now you can see కాండం మీద నష్ట లక్షణాలు ఉన్నాయా, పూత మీద నష్ట లక్షణాలు ఉన్నాయా, ఆకుల మీద నష్ట లక్షణాలు ఉన్నాయా, దూదిపైన నష్ట లక్షణాలు ఉన్నాయా, కాండం మీద నష్ట లక్షణాలు ఉన్నాయా. సో కాయలు, పూత, ఆకులు, దూది, కాండము, మొక్కంతటికి. So basically now if you are having crop is having any problem, you should say yes, isn't it? Yes to one of the problem. A crop problem should appear in any part actually. We divided the plant into parts. Either problem should appear in bolls, flowers, leaves, stem, all kinds of. This is the cotton. If you are unable to say yes to any question, your crop is fine. Okay. So suppose you say కాయల మీద నష్ట లక్షణాలు ఉన్నాయి. సరే. Then second level questions will come. కాయలు పూర్తిగా పెరగక ముందుగా పగులుతున్నాయా, కాయలు పూర్తిగా పెరగక ముందుగా రాలిపోతున్నాయా, కాయలపై మచ్చలు ఉన్నాయా, కాయలపై పురుగులు ఉన్నాయా. ఓకే. సో ఇది. సో ఇఫ్ ఐ సే దిస్, సో ఇక్కడ సుమారు 50 mm పొడవు, శరీరంపై పల్చగా వెంట్రుకలు కలిగిన పురుగులు తల భాగం కాయ లోపలికి దూర్చి కాయలను తింటున్నదా. ఓకే. So in this way you say ఎరుపు రంగు కల రెక్కలపై 2 నల్లటి మచ్చలు కలిగిన బొద్దింక లాంటి పురుగులు ఉన్నాయా? నల్లని లేదా ఊదా రంగు మచ్చల పురుగులు ఉన్నాయా? If I say yes, this is the problem. శనగపచ్చ పురుగు, advise రసాయన సలహా, saying like that. So you can say, idokati. Just you say, if you click another thing, murikinilli. So what I am doing is that you can play with this tool and give us feedback. For example, so something is happening, understand risk, I don't know why this, I will correct it. So this one, so you can follow English or something like that. You can also follow English. Do you observe any damage on balls? Do you observe any damage on flowers? Do you observe any damage on leaves? Do you observe any damage on link? Do you observe any stem damage? Do you observe it like that? Okay. So you say, for example, you are having damage on flowers. Do you observe, do you detect any drying of terminal buds? Do you observe any shedding of flowers? Is there a delay in blooming? Do you observe do flower buds have holes? You can click anything, no problem. So Helicoverpa, Armagera, Bolbon, like that. Anybody is using it? Mobile phone? Crapdarpan.in. You type the Crapdarpan, you can go to smartphone and use it. So this is the logic actually. What we are doing is that we are identified sequence of questions for all the problems and developed the algorithm. And it took about 2 years to develop this system. And we are ready for the cotton crop. Now we are extending to rice crop. Okay. This is whitefly, aphids, strips, everything. This is a mealybug, jacids, zinc efficiency. Huh? Anything? So, where is the message here? Is there? Yeah.
Just I posted the message, sir, to all the participants to post the questions in the chat.
Chat and okay, they are visiting Crapdarpan. They can visit the Crapdarpan and test it. Okay. So okay. So overall the idea is that being semi-literate, farmer is able to identify the generalized visual symptoms of the crop. The low-level visual perceptions of the field problems of the given crop can be collected from the subject matter specialist. The Crapdarpan contains a hierarchy of visual perceptions of field problems that consist of generalized, middle-level, lower-level perceptions. The Crapdarpan helps the farmer to identify the field problem by confirming the corresponding low-level perceptions and obtain agro advice. This is a Crapdarpan. So we gave it a name as a Crapdarpan. And this is we developed 2 protocols and a lot of things, a lot of effort has been there. The cotton crop is already there. People are liking this system. And we have already explained to Agriculture University. We had 5 revisions of the system. After 5 revisions, I am showing this prototype. If you have any problem, let me know. It should work actually. This is a demo of Crapdarpan, www.crapdarpan.in. You can go and visit. And the security, you can go ahead and just visit. And you can also, if you have any any farmers, please forward this URL to all the farmers. Let them give that feedback. They can use this system now. Suppose farmer is using the crop. Suppose you can English or Telugu, you can go for it. Then you can click this. But my assumption is that farmer is having a smartphone. He is walking in the field. He is walking in the field, seeing the field, answering these questions. Okay. So it should be feasible, I think. We are going to add photographs also, but with the only questions we resolve this problem. So on this way, then for this is the kind of Telugu. You say Puta Mida Lakshalakshanalai ante yes antadu. Puta Ravadam Alasyam avutuna yes. Basuram Lopam. So inside what is happening, because a lot of, this is the tree we have built actually, because there are 40 problems. Each problem has several symptoms. All these things we are, for example, bolt damage, the premature opening balls, we click this in this way, it is appearing like this. Yeah, so cotton, lint damage, lint color damage. We have got trees, we got to build the trees, and system is performing those operations. So overall, so the proposed systems, whatever we propose, they are scalable. They can extend to all the crops, all the farmers, all the regions, and all the countries also can use these systems. They are location specific, personalized. They can be language, any language. For example, if we have developed English and Telugu, we can extend it to all 24 languages. Okay, there is no problem. And dialectic specific, even Telugu is spoken a different way, we can also shoot that one. So the overall conclusion is that the ISAGU, village level ISAGU and crop darpan systems have potential to help poor, marginal, illiterate farmers, and overall the effort is made to build a system to touch and benefit every family. It aims to improve the income of poor and marginal farmers, provides cost-effective opportunity to help the farmers. So overall, I feel that if we implement these systems all over India, it can lead to a next green revolution, and it can be a good cloud computing platform. So with this, I close the talk. Thank you very much. So if any doubts, I will take it actually. Stop. I'm stopping now. Okay. Yeah.
Yes, my dear participants, please, after having the exhaustive lecture and different insights, which we did not had a thought that.
So talk came out clearly. Is okay. So it's okay. Or any confusion? So
no, everything is very perfect, sir. Actually, we had no awareness. In fact, the systems like this, ISAGU, village level SAGU, and even either fund. After having this lecture, in fact, it's there is a very much requirement to everybody, to motivate the farmers.
Oh yeah.
My dear participants, please, it's a very great opportunity to all of you to interact with us, sir. Please unmute yourself and you can interact directly.
Yeah, you can ask any doubts. Whatever positive, negative, I'm here to take it, but no problem. So currently, I'm busy in developing crop darpan. Most of the energy is going on crop darpan, and we are trying to extend for rice crop. Things are a little bit difficult in rice because most of the problems are leaf only. So there we are not finding generalization, specialization. We are making efforts to put the questions with signature images. That is the idea. We have got it. So with that, we are doing it. Okay.
Participants, you can interact here.
Okay, then let them send a mail to me if they have any doubts. Okay. Yeah.
Yes, sir. Thank you, sir. 1 second. Thank you very much, sir. Really, it was a different session by you. As you said very rightly at the beginning that definitely I will motivate you. No doubt that you have motivated every participant, sir, because all other lectures are very something different from this, because as agriculture is very, very important. In fact, our nation is mainly depending on this. It's a different sort of thought for every individual. No doubt that people are really aware of this. Now let me just give my thoughts on this as well, on our lecture, sir. Just what in fact participants might have got the different insights. Once again, thank you, sir, on my personal behalf and on behalf of our institution, on behalf of our coordinator, Dr. K. Rameshwari Garu. In fact, sir has covered in-depth and complete insights on ESAGU, crop darpan. In fact, there is an opportunity in the country or even in the world to concentrate, as sir said rightly, that we will give problems, then people can work on this. In fact, sir has already posed so many questions, so many problems for research. Definitely, the interest of participants can.
Yeah, people can attend those conferences. Ask them to register, and let us see. I will also be in touch with you.
Yeah, sure, sir. Once again, I'll send that brochure to all the participants through email.
Yeah, okay.
I'll download it and I'll send. I'll forward the same to all the participants, sir.
Yeah, URLs you can forward. Okay.
Yeah, sure, sir.
Okay, thank you very much. Thank you.
Just 1 minute, sir.
Yeah, Chapan.
In fact, you have covered in a very right fashion personalized information systems, PISS, distribution system, which is very much scalable and efficient in terms of time. And no doubt that what I personally feel that it's really a trailer to all the members who have a thought on agriculture, especially, and even you said that you have even started implementation ESAGU for fish ponds and even for farms, ESAGU IT-based personalized agriculture. And no doubt it is not possible for every individual to visit for physical verification of the farms. As you said, that is a very the developer system is very much beneficial to all the members, as it is scalable, time saving, time will be saved, and very much beneficial. Then experience of farm, knowledgeable farms we have to, and the level of agriculture advisory system, and generic hierarchy. In fact, after seeing your diagram, sir, then I think people could have thought about a decision tree, data structure decision tree. So really, we are very happy with that. And the visual recognition with humans in the loop. And in fact, you have given 2 questions, sir. As a doctor is in a position to tell some sort of suggestions or remarks after seeing the black and white images of X-ray. Why not agriculture scientist? Really, it's a very good thought. In fact, they are supposed to do, but we really have to understand in reality what sort of practical problems, support, coordination among the right members in the right time, which should be implemented in the synchronized fashion. At the same time, whatever the systems which you develop, no doubt it's a crop diagnostic tool. In fact, at this point of time, just I got a thought that like a diagnostic centers for health, then why don't we have diagnostic centers for crops? Maybe in one diagnostic centers lab, center, at least in one city, or at least one in the district. Then no doubt it's scalable for crops, farmers, regions, countries. There is no all independent of all these things, and there is no location specific personal information system. And ESAGU, it's a very beautiful systems. In fact, very much we got complete insights, sir. We are very happy and very much very interesting topics. ESAGU, village level ESAGU, crop darpan, everything. And even I have demonstrated the e-darpan by logging into the e-darpan domain. As a whole, sir, I really once again thank from my side and even on behalf of my personal coordinator, Dr. K. Rameshwari Garu, for your kind acceptance and sparing your valuable time with us for your very great lecture, which will definitely boost or motivate the participants in a different direction, which country in fact is required.
The informal discussion also let me know, actually comments later also.
Yes, sir. Sure, sir.
Basically, I want to know feedback because people have different thoughts. If they are inside, then the system cannot be improved actually. If something bad about system, they have to tell us now only.
That's true, sir.
We are doing it. Okay.
My dear participants, please still you have time to share your thoughts. As sir said, whether it is positive or negative, you can say some sort of suggestions, or you can express your opinions so that it is good. Participants, some of you take an opportunity to express your feelings, about this lecture. Okay, in chat box they are telling it's yeah. Dr. Madhav Reddy, sir.
Yeah, the noise is coming, sir. It's talking. Okay.
Sir, audio disturbance is coming, sir. Audio is not clear, sir. Madhav Reddy, sir. Madhav Reddy garu.
Sir, hello, sir. Janardhan, sir.
Yes, sir. Please proceed, sir. Now it's very clear.
Sir, good evening, Krishna Reddy, sir.
Yeah. Good evening. Good afternoon. Cheppandi. Cheppandi, sir.
Engineering, sir, working in Mahatma Gandhi Institute of Technology, Hyderabad, sir. Sir, you are.
Voice.
Cheppandi, Madhav Reddy garu.
Sir, agriculture field only. Sir.
Cheppandi.
Thank you very much, sir. Exhausting lecture you have given. I also came from agriculture background only, but you explain e-sagu, it is a new word, sir. I didn't listen this presentation in e-sagu and darfan. And wherever the questions are there, like Raju sir explained, why don't you install this diagnostic center for plants? It's a very good idea, sir. Now that is also proposed to government and implemented. Very happy, sir, for farmers, especially. Now we have faced so many problems while doing in a crop. What is it? Rice and cotton and groundnuts. We are facing so many problems to diagnose all this plant and which pesticides we are using to kill that germs. All this. Thank you so much, sir. Your wonderful presentation has given. Apart from machine learning, all this we are listening. Sir, last 3 days we are listening only neural networks, fuzzy logic, and what is the deep learning and all this. So it is apart from that, it is a new technique, sir. Very happy.
So we are going to extend crop darpan to groundnut also. So the prototype has been built for cotton. We want to investigate details vertically. So it will go horizontally now. We are working for rice. Then after that, we will extend it to all the crops. That is the problem. Currently, the crop darpan can only identify one problem. We are going to extend to multiple problems also. We are going to piggyback with the images and voice also. So these are the things we are working actually, because it is very difficult to build a system which will work, because the research paper publication is different and building the systems which will work is different actually. We'll get a lot of issues actually, because otherwise we are going with the society. If something is not working, I can't put on the website. Otherwise, they will put a case on me. So all these issues will be there. Yeah. Okay, Nandi. Thank you, Raju garu. Thank you.
Sir, thank you very much, sir. Once again, thank you very much, sir.
Okay, shall I leave now? Okay.
Yes, sir. Thank you, sir. Namaste, sir.
Okay, bye. Thank you.
Bye. Yeah, participants, please, you can submit our feedback form. The link will be still will be active more 15 minutes. Dear participants, please submit your feedback form. Submit your feedback for today, that is today.